Right. Okay. Check students. Can someone check whether you can unmute your video or audio? I just want to get it confirmed before we start. As students on the Zoom, can someone confirm quickly? If you can't unmute yourself or if you can't switch on your video, you can someone confirm that? No, it's not about both. Then okay, okay, right. Then we'll start in 5 to 10 more minutes. Okay, okay. Stay. That won't matter. We'll start at 8:05, right? 5 minutes past 8. Until that, you can share the message, and also you can make sure that you have the PDF printed and everything is set. Then we'll start in 5 more minutes because I can see students are still joining. Therefore, we'll start in 5 more minutes. Okay. Okay, then let's start. Right. Sorry. Right. Check whether everything is okay. If you have any issues, put it on the chat, right? Regarding anything, any technical difficulty, anything, put it on the chat. And also, students who are joining through YouTube, again, you can send a message to the YouTube live as well, but it might take some time to respond. That doesn't matter. You can just send a message, but especially for the YouTube live, don't send anything unwanted. Okay, everything should be related to the seminar, otherwise you will be removed. Hari? Okay, then I think enough time. We can start, I guess. Hari, shall we start then? Okay, right. There's a message saying that students are still joining. Can we wait for a few minutes? Okay, then we'll wait. We won't start, but I'll just give you a small introduction on what is happening today and what we are supposed to do. Then we'll continue. Hari? Right. Then, okay, I hope that I guess that most of the students and also the YouTube live is here. We have the YouTube live as well. If you want, you can join that. If students on the YouTube live, if you want, you can join the WhatsApp group. If you are not, I have sent the link to the chat and the YouTube live chat. Then you can join the Zoom meeting as well. It's up to you whether to join, whether you want to join the YouTube live or whether you're joining the Zoom. Right? It's up to you. It doesn't matter. And also, what else? හරි okay then we'll slowly start the proceedings හරි තාමත් ළමයි එනවා මං හිතන්නේ කමක් නැහැ and now right so today this is what's going to happen today we will be finishing the electrochemistry part and also if you have any issues you can put it on the chat on the Zoom chat uh, but again I'll take some time to respond Hari it will take some time okay then just checking whether everything is fine before we start. හරි shape නේ අවුලක් නෑ වගේ. හරි. Okay, right. Then today will be the second day of your seminar series. We will be covering the electrochemistry part. I guess which is more important for you students than what we did on the first day, which was the concept of mole, because that was covering a general topic was covering a fundamental topic which had less marks directly but had indirect importance when it comes to your paper, the concept of mole, which we did on previous Tuesday. And today we will be covering the entire electrochemistry lesson, which has a direct value, which they will normally give a essay question. Normally the 9th essay question, the first part of the essay question will be given from electrochemistry, considering the previous papers, right? And I have sent you the tute, which contains a few past paper questions from recent years and also few term test questions as well. So I guess that you have a printout of it, then it will be much more easier to continue. But if you haven't got a printout, then it doesn't matter for the moment. You can get it later even if you want, because we will be using this in the final part of our seminar. So first of all, we will be covering all the basic theory. So we will be covering the entire lesson. I'll explain how the lesson proceeds and what sections do we have. And afterwards, once we finish the entire lesson, we will be start doing questions, right? That's our plan for the day. So I expect you to continue for the entire seminar, because otherwise no point, right? So you have joined this seminar for a reason. Therefore, make sure that you continue it until it ends, right? අන්තිම විනාඩිය වෙනකම්ම කොහොම හරි ඉන්න බලාගෙන එමු. And I will be giving an interval in 2 hours, then we'll continue for another 2 hours. That's our plan, right? Okay, then what else? And if there is any student who joined after the first seminar, after our first seminar, if you are on the group, I have sent the previous seminar recording. If you want, you can go through it as well. It's on the YouTube as well. It's as a YouTube live, still on the YouTube channel. Hari? Then I guess that's it for as notices. If I remember anything else, I'll inform later. Hari? Hari. I think එටික තමයිනේ. Yeah. So I think that's it. We can start. Hari. Then electrochemistry, right? Electrochemistry. And also this won't be the end of the seminar series. Officially, we have only published details about the first 2 days, which was the concept of mole and the electrochemistry session. But as I said, depending on your suggestions and depending on your interest, we might have a few more sessions in the future as well. Before future means recent future, before your O levels. Hari. And after your A levels, regarding your A levels, we will have few more sessions, and regarding our classes, everything will be informed on the group. So no need to bother about that at the moment, but those will also happen on the group. So after today's session, you can remain on the group, because a lot of other sessions will be happening in the future as well. Harid? Right. Okay. Then that's it for notices. For the moment, we'll start the session regarding electrochemistry. Right. Then. Right. Oh, you mean as a separate session? We'll see. Yeah, there are a few suggestions. I sent a suggestion form as well after the previous seminar. So in that previous seminar, there were a few suggestions. Most of the students were actually suggesting to do a electrochemistry seminar, which we are actually doing anyways. And there were a few more suggestions. And one suggestion was, can we do past papers? And we'll see. Right, depending on the requirement, I can arrange a session, but I need some sort of a requirement. Otherwise, no point just arranging a session. No, I'll inform you what our future plan will be. Most probably on tomorrow, right, or day after tomorrow maximum. I need to arrange it, and then I'll inform you. Hari. Therefore, stay patient. Hari. Right, then put the topic electrochemistry. And I want everyone to finish the entire electrochemistry unit with no issues. Therefore, focus. That's the only thing I expect from your side, right? I said this in the previous seminar as well. Focus. If you can focus and stay for 4 hours, then the unit will be covered, right? There won't be a single doubt. I can promise it from my side, but you need to focus. And if you have questions, you can ask. I'll explain it any amount of time, and then you will understand it. Hari, put the topic electrochemistry. Electrochemistry. Electrochemistry is the 12th unit in your syllabus, ne? For the grade 11 textbook, it's the 12th unit. It's the 12th unit. Under electrochemistry, there are 3 main topics. Does anyone know the 3 main topics? What are the 3 main topics under electrochemistry? Can someone send it to the chat? or the YouTube live. What are the three main topics on the electrochemistry? And also students may note that if you are continuing through the YouTube live, always for a YouTube live, there is a, I think, 10 to 15 second delay, right? That's not our issue. That's how a YouTube live works. You might not be aware of it. Therefore, for the Zoom students, there is no delay. Then there can be a certain confusion because of that 15-second delay, right? Now, for the YouTube live students, if you are hearing something that was said 15 seconds ago, you are put pity passing in, that's how it is. So make sure that you are aware of the situation. Hari? Yeah. So the first part is electrochemical cells. The first part is electrochemical cell. And the second part is electrolysis. Good. What's the third part? Yeah. What's the third part? No, it's not electroplating. Electroplating is a practical application of electrolysis. Yeah, it's rusting or else corrosion of metals. That's the proper topic, right? It's corrosion of metals. So these three are the main topics. Now, before we start a lesson, since this is a sort of a big lesson, main lesson, you need to know what main topics are we going to study today, right? So these three are the give me a minute. These three are the main topics. Is it clear? When it comes to your A levels, Hari, when it comes to your A levels, mainly we will be only focusing on these two. This one and this one. We don't talk about corrosion of metals. That will be only for O levels. In your A levels, we will be further learning about electrochemical cells and electrolysis. Sorry. Now, for most of the students, all three parts are difficult. The basic idea has not been properly given in your O-level syllabus. That's the main reason for students to feel that this lesson is difficult, that we have to study a lot. But today I will show you how an electrochemical cell works and how electrolysis works and what are the logics behind the cell or a electrolysis cell, electrolytic cell. And afterwards, you will be able to easily memorize or easily understand and easily logically get the answers for especially the reactions and cathodes, anodes, positive and negative ends, right? So that will be really easy. Is it clear? These days, before the seminar, what you did was you studied that for this cell, this is the reaction, this is the reaction, this is the anode, this is the cathode, and this is the positive end, this is the negative end. But from here onwards, I'll show you how you can logically get it. So if a student feels that, no, I don't want to get it logically, I can just study, then that's up to you. It's up to you. For most students, that's difficult, but there can be a student, rather than understanding it logically, you can study. Then no need to no need to do what I am saying. You can just simply study. It's up to you. Hari. So that's for the electrochemical cell and electrolysis. Under these two parts, the main part is about understanding the cell and writing the reactions. And then there are few practical applications such as electroplating, down cell. I'm just trying to give you a brief idea. You might have heard of these terms in your syllabus. And when it comes to corrosion of metal, it's something completely different. Mainly, we are focusing about the corrosion of iron, right, which is rusting. And then we will be learning how the reactions work there and how we can how the corrosion of iron gets accelerated, what are the factors and how does it get decreased or decelerated, and how can we protect iron from corroding. It's a completely different theory part, right? Is that clear? So that will be it for the lesson, right? So that's the summary. For your O-level paper, normally when they are giving a question, they will pick one topic of these three for a year and then they will be giving a question. Now, for an example, I can't remember what was given in the previous year, but somehow they normally will pick one. If it is corrosion of iron, then that will be given. If it is electrolysis, then that will be given. So you need to be able to know all three parts because we can't exactly say what will they give on this year, right? So you need to know, you need to have a better idea on all three sections. I hope that's clear. Right, then you can write the main topic electrochemistry, electrochemical cells, electrolysis, and corrosion of metal. Quickly write down. Adi. Most part of the seminar will be on doing theory because once you understand the theory, you can quickly do the questions, right? So we won't spend a lot of time doing questions today because we have a significant amount of theory to be covered. Then we'll start doing questions in the final 1.5 hour. Okay, shape again, right? Okay, write down the main three topics, then we'll continue. Well, is it okay? Hurry. If you have written this down, then we can continue. Then write the first main topic, electrochemical cells. Electrochemical cells. Electrochemical cells. Right? Electrochemical cells. In your syllabus, they expect you to know. Now pay attention, right? Now we are going to develop few logics for electrochemical cells. Now that there's one main disadvantage trying to understand logics. The disadvantage is that there are a lot of advantages. It's easy to understand. Then you need a very small amount of space in your brain because we don't memorize theory, and it's long term easy to understand or easy to memorize. Therefore, understanding logical is the method, the proper method. But there's one significant disadvantage, which is since you are building a logic, I will explain the logic, and then all of the theory will be memorized, or all of the theory will be remembered or understood according to that logic. So if you are unable to completely understand the logic, then at one point, if you get it wrong, all of the answers will be wrong since you are not studying anything. Is it clear? Now, if you are studying, let's say you are studying 5 points. If you forget two, you know the other three. But since you are getting all the points logically, since you are deriving all the points logically, if you forget the logic, if you don't understand the logic properly, you have a chance of getting all 5 wrong. Is that clear? Therefore, pay close attention. Now, what's an electrochemical cell? If I draw a small sketch, there are a lot of types of electrochemical cells, but in all levels, you will be learning the most simplest structure, right? Then now, for an example, in your textbooks, when they say an electrochemical cell, you remember this. You all of us students recognize this as a electrochemical cells. Hari, this will be known as a metal ion cell in A levels. No need to know this term. In A levels, we call this cell a metal and a metal ion. So you can see these are metals, right? I'll take example later, but these are metals. And inside the container as a liquid or as an aqueous solution, it contains metal ions, right? For an example, if you have copper sulfate as a liquid, as an aqueous solution, then you have copper 2 plus, that's a metal ion, right? So there are various types of cells, but for your O levels, we only have this type of cell, right? Metal ion cell. Okay, then I'll just make it more clear. Right. Then what do we do? This is a cell. And we can actually get electricity out of this cell. We can convert the chemical energy which is in the cell to electrical energy. And that can be proven by connecting to conducting wires. Let's say if we connect it to a bulb, then you can light up this bulb. Therefore, it's true that you can get electricity out of this system, but we are not interested about that part. That's just a simple circuit. This is the cell. If you want, you can say this is the cell. So if you want, you can connect something and get the output. So this will be the cell, right? A cell is a source of electricity, right? We are using this cell to generate electricity. Electricity will be generated out of the chemical energy. I think you might not, it's not necessary to know the energy conversions, but inside this cell, chemical reactions will happen. Chemical reactions will happen. As a result, electricity will be produced. That's simple as that. Is it clear? Now, there are few things that they ask regarding a cell. I'll try to write all of the points which they are normally asking in your O levels. If I miss something, you better correct me. Harida, you can update me. First, they will be asking to identify. I'm not considering order. I'm just writing all the things. We'll make an order later. They are asking us to identify the anode, asking us to identify the cathode. What is the anode? What is the cathode? This side or that side, right? Then they will be asking about the anode reaction. I'll write that AR, anode reaction. Then cathode reaction. Then the total reaction, or the final reaction. So you can add all the reactions in a way that electrons will be simplified. Can you remember the anode reaction, cathode reaction, and the total reaction? And then they can ask, what is the positive end? Positive end. Sorry. And the negative end. Right? Plus minus n koi පැත්තරද? Finally, they will ask the electron flow. The electron flow. And the current flow. I current flow. They will ask about these, right? And also, if they want, they can ask, what can they ask? Any observations? Any particular observations that the anode dissolved or it started bubbling a gas? Something like that, right? Ion formation at terminals, yeah. So some observation, right? What can happen? What ion did form? What gas did form, right? I don't know whether you have precipitates. What precipitate did form? Some physical observations, rather some chemical or some practical observations. So they can ask about observations depending on what happened. Or did a color change happen? Something related to observations. So do we have anything else apart from this? Any other answers? Do we have anything else? Are you asking about the recording on the live chat? So this live will be available. It's better if you can join live, but if not, it's up to you. I think. This is it, right? This is it basically. Ne? Then in your syllabus they have given 3 cells. In your syllabus they have given what's TR? Total reaction. This is the anodic reaction, cathodic reaction, and the total reaction. So you simply add those two reactions in a way that electrons will be cancelled out or simplified, and then you get the total reaction, right? Then in your syllabus, they have given us 3 cells, and then they expect us to write any of these for all the 3 cells. That's what is for electrochemistry. Once I teach you how to derive all of these, electrochemistry is done. Is it clear? Are we okay up to now? Can someone confirm whether everything is okay? Avulak nadda? Do you understand everything? Is it okay? Avulak naha ne? Right. Good. Then let's see how to get this. How to derive what's anode, what's cathode, what's anodic reaction, what's cathodic reaction, everything, right? To start proceedings, the most important thing which you want to know, which you are supposed to know, is the activity series. Activity series කියලා නේද කියන්නේ in O levels, because in the A levels we have a separate name. It's electrochemical series in A levels. Is it activity series? Yeah. Also they ask about the oxidations and the reductions. I missed it. Oxidations and the reductions. Right. Good. Is it a activity series or do we have another name? Can someone confirm? Activity series කියලා නේද කියන්නේ? Yeah. Okay. It's a activity series. Okay. Good. Hari. Right. Okay. Also reactivity series. It can vary, but that's the idea. Right? How can I understand? I'll answer that later. Hari. If you have a question which is not related to this part, you can ask later on WhatsApp, Hari, because then otherwise it will disrupt the flow of the seminar. Hari. Now we have the activity series and we want to memorize the activity series. So activity series is not something which they give, which we want to memorize under electrochemistry. It's in my knowledge, according to my knowledge, activity series is somewhere else in your syllabus. So for the moment, I'll only explain the elements which you want to know for this part. Hari, we don't want the entire activity series or the entire activity series which is given in your syllabus for the electrochemistry part. We want a very small amount of elements. So I'll explain what elements we actually want. Hari, we actually want, I think, 3. What else do we want? Okay, it's like this. If you consider the activity series for electrochemistry, you just need to know that hydrogen is in the middle. I hope you know that, right? Hydrogen is the middle. It's considered as the origin of activity series. And then copper is below the hydrogen, not exactly below, but it's below hydrogen. There can be few more elements in the middle or few more compounds in the middle, doesn't matter. And hydrogen is above at the activity series. Hari, hydrogen is above the activity series. And for uh, for corrosion, considering the final part of the lesson, which is corroding of metals or the corrosion of metals, we again have to redefine, we again have to learn few more elements regarding the activity series. So since iron is being involved, iron, magnesium, zinc, those things for the activity series will be taught later. Simply for the electrochemistry part, you just need to know this order. Sodium is on top. In the middle, we have hydrogen, and on the bottom, we have copper. If I want something else to be added, I'll inform. So that's it. So for the activity series, මෙච්චරයි දැනන් ඉන්න ඕනේ. Only this. Very easy නේ. අවුලක් නැහැ නේ මෙච්චරයි දැනන් ඉන්න ඕනේ. හරි. Then I'll take one example of your syllabus and I'll explain how these things can be given, and then we'll try to do the other examples. I'll ask you to do the next 2 examples on your own. Then you will see how easy this is. Harida. What is mentioned as red? Where is it red? Reduction, the oxidations and reductions, right? Hari. Is this clear? Can I erase this? Is it okay, Harida? It's just sodium, hydrogen, copper. That's the activity series. Sorry, no need to write it. You can write it later because you haven't written anything. But for the moment, you can write it somewhere on your note. Hari, because I will be using it. I want space, therefore I'll erase it. Hari. Hari. Shall we get a separate page or no? It doesn't matter. Right. Now we are actually starting to develop a logic. Hari bala ganna karana හැටි. Let's take this container. Let's take this cell. I'll take one example. In your syllabus, shall we actually write? So no need to write anything, right? No need to write anything. But put a subtopic under electrochemistry. Put a subtopic under electrochemistry. Put Roman number 1 and write. Put Roman number 1 and write. Hari. Put Roman number 1 and write. Put Roman number 1 and write. Let's take one example in your syllabus given is this sodium chloride aqueous. And then here you have carbon electrodes. I'll explain everything. Carbon electrodes and carbon electrodes. For electrochemistry, for cells, there's no subtopic. It's just the cell. So this is the first cell. You can put first cell. This is the first example. Hari. How can I remember the activity series? You just need to remember 3. Sodium, hydrogen, copper. That's it for the moment, right? That's it for the moment. You can remember 3, right? Hydrogen in the middle, sodium on the top, and copper on the bottom. So this is the first cell. You can put Roman number 1, first subtopic. This is the first chemical cell. There's not subtopic. You can just write first chemical cell. After writing it, draw a small diagram like this. Very small diagram. A very small diagram. Just to give you an idea on what we are going to learn before I start explaining everything. Then you know we all are on the same page. Then you know what's happening. Hari? Then I will quickly move on. Hari? Right. Is it clear? Sorry, my bad. Sorry. Yeah, thank you for pointing out. These things should be changed. Sorry. Quickly change this. I wasn't actually paying attention. This should be zinc. This should be copper. Sorry. And this is H2SO4. No, okay. Write it like this. It's H2SO4. There's no name now for these cells. We actually have names, but no need to write any names. It's not expected now. This is known as a no, for all of the cells, the common term is galvanic cell. Hari, but no need for this. I think this is the Daniel cell. In A levels, you have terms, but even in A levels, they don't expect you to memorize the names of the cells. Hari, you can just write the first cell and then you can draw a small diagram. The solution is H2SO4, which is sulfuric acid. H2SO4, which is sulfuric. This is the first example given on your textbook. This is the first example given on your textbook. Hari. Now, can we continue? Shall we continue? Hari. Then zinc is also required. Ne? Zinc is required. Yeah, iron is required. Okay. Okay, fine. Hari. Since we have zinc also for the activity series, it should go like this: sodium, zinc, hydrogen, and then copper. Add zinc as well. Hari, add zinc as well. That's also required. And add the iron as well, which will be wanted later. Write this somewhere, not on the note, somewhere, because this is required to do the comparisons to explain. Then it's easy to explain. This is the activity series, the components which we want. Hari, there another right. Now we'll quickly move on. Now this is the cell. Now they will give you the cell and ask all of these things which we wrote earlier. They will ask, write the anode, identify the cathode, everything. Hari. Now the first step is you need to understand what is anode and what is cathode. Hari, now we are actually, we have written all the theory which is required. Now I'm going to explain. Now pay attention. Don't write anything. Pay attention. Hari, the first thing is we need to know what is anode, what is cathode. Does anyone know what is anode, what is cathode? Can someone answer quickly? Can someone answer quickly what is anode and what is cathode? Give me answers. Quickly, Ragadone. Right. So I can see a few incorrect answers coming. That's what I actually wanted. Now the most basic answer. No, I'm not asking what is anode, what is cathode. In the sense, I don't want copper is anode, zinc is cathode. I'm not asking for this cell. I'm asking generally, if someone asks you what is an anode or what is a cathode, what will you give as an answer? All right. Now I can see there are a few incorrect answers as well. That's a most common incorrect answer which I can expect from a O-level student. Anode is not a positive end or cathode is not a negative end, or it's not even vice versa, right? That's not the definition, right? That's not the definition. Whether it's a negative terminal or a positive terminal, that's not the definition. That's the first thing you get wrong. That's not a definition because if you can remember for electrochemical series and electrolysis for the electrochemical cells and electrolytic cells, the terminals, the positivity and negativity of anode will change, right? For an electrochemical cell, anode is negative. If you can't remember, doesn't matter. If you don't know, doesn't matter. I'm just referring it to it. For an electrolytic cell, anode is positive. Therefore, the first main mistake all our students do is try to remember anodes and cathodes using the positivity and negativity of the terminal, which is wrong. Which is wrong. From here onwards, we don't think like that. Anode is the place where oxidation happens, and cathode is the place where reduction happens. That's it. We don't care about the positivity or the negativity because it's not consistent. Then for electrochemical cells, you will have to remember one thing, and for electrolytic cells, you will have to remember another one. Therefore, we ignore that. Simply, you need to know that. What is anode? We can write this later, right? I will give you more than enough time to write. I will guide you for a note with a note. Therefore, no need to write now. Anode is a place, right? Anode is a place where oxidation happens. It's constant. It's consistent. Doesn't matter whether we are talking about an electrolytic cell later, or doesn't matter whether we are talking about a electrochemical cell here. Always, if oxidation happens somewhere, then that place is known as an anode. If a reduction happens, then that is known as, don't ask what's red later, it's reduction, right? Then that's known as the cathode. Is it clear? Right. Now, what is oxidation? What is reduction? Quickly tell me. What is oxidation? I can see few answers already. What is oxidation? What is reduction? Yeah. Anode, oxidation is donating or removing electrons, removal of electrons, and cathode is accepting, accepting electrons. Is that clear? Do you know that? Do you know what's oxidation and what is reduction? Oxidation is removing electrons. I'll write it here shortly for the moment. Removing electrons. And reduction is accepting electrons. Is it clear? Accepting electrons. Now we have a clear idea on the basic concepts. We have a clear idea on the basic concepts. Now we'll move on to this side. We'll move on to this side. No need to memorize anything. You just make sure that everything you are focusing, that's it. Once you write the note, everything will be in one place, then you will perfectly understand. Now this is the activity series. This is the activity series. Is this just a random order, or is there any logic inside the activity series? According to what order have they arranged the activity series? What property are we focusing? So that property is high or low for the elements on the top, and that property is again high or low, or reactivity. Okay, reactivity. That's depending on the reactivity. That's the place you get O-level electrochemistry difficult, because they don't actually teach you the actual concept of the electrochemical series. They just say that it's depending on the reactivity, which is true, but that's not the important part which you are supposed to know, right? From here onwards, you can know this, then this will make your life really easy, right? From top to bottom, the preference to oxidize will reduce. That's what you want to know. So the basic idea of now you know the activity series. The basic idea of the activity series is elements which are on the top like to oxidize. You didn't know that, right? Now this will make your life really easy. And elements on the bottom will generally like to reduce. It's a relative thing, right? So the idea is sodium likes to oxidize than zinc. Zinc likes to oxidize than iron. Iron prefers to oxidize than hydrogen. Hydrogen prefers to oxidize than copper. Or else you can read it the other way. If someone doesn't prefer to oxidize, then what are the options left? I don't want to oxidize. Then what can I do? Quickly, what can I do if I don't want to oxidize? Can I just stay? No, I can't just stay. If someone doesn't want to oxidize, then that person should do, that substance have to reduce. Is it clear? Then you can read it the other way. Copper likes to reduce than hydrogen. Hydrogen likes to reduce than iron. Iron likes to reduce than zinc. Zinc likes to reduce than sodium. So is that clear? Is that logic clear? Right, now you get the idea. Now that's the actual use of the activity series. That's the actual reason to teach the activity series. I don't know why they don't teach that in O levels. Then that will make your life really easy understanding what's the cathode and what's the anode. Right? Okay, I'll repeat it again. So what I said was, first thing you need to know is what is anode, what is cathode. Simply the place which oxidizing happens is anode. Simply the place where reduction happens is cathode. Reduction is accepting electrons and oxidation is removing electrons. I hope that's okay. Hurry. Moving on. This is the activity series. This is not the complete activity series. There are a few more elements in the middle, but we don't care about those. This is what we want for the moment. And considering this electrochemical series, the idea of the activity series is going down the series, preference to reduce will increase, preference to oxidize will decrease. Therefore, this is the one which likes to oxidize the most, and this is the one which likes to reduce the most. Is that clear? Is it clear? That should be perfectly clear. Otherwise, we can't continue from here onwards. Good. Then we'll consider this example. Sorry. We'll consider this example. Hari, me balanna. Now, looking at this cell, tell me, we are only looking at this rod and this rod. We are not paying attention anywhere here, right? We are only considering this rod and this rod. Is it clear? Okay. Looking at these rods, tell me, Hari? No, it depends. You can't say hydrogen will reduce always. Hydrogen likes to reduce than all of these three, but it doesn't like to reduce than copper. It's just a relative concept. You can't say hydrogen will always reduce. So I'll erase these. These might mislead you. It's just a concept. Hurry. Going down the group, preference to reduce will increase. Going up the group, preference to oxidize will increase. Hurry. Now looking at this cell, tell me, we have a zinc rod and we have a copper rod. Hurry. Quickly tell me, out of zinc and copper, what likes to oxidize the most? Is it zinc or is it copper? Looking now, you know the logic. Is it zinc or is it copper? Good. I can see you getting the answer. It's easily zinc, right? It's easily zinc. Now you can say, okay, I know the activity series and I know going up the group, the preference to oxidize will increase. Copper is here, zinc is here. Therefore, zinc will write to oxidize. Is it clear? Now, isn't it easy? Now, zinc will write to oxidize. Now, therefore, zinc will in this rod, the oxidation will happen. Therefore, copper has no option but to reduce. And copper actually likes to reduce. No matter. අවුලක් නෑ දෙන්න කතා කරලා තමයි කරන්නේ. They check who likes the most to oxidize. Then that person will oxidize and the other will happily reduce. Is it clear? Right. Now tell me, a place where oxidation happen is known as what? A place where oxidation happen is known as what? The anode. Now this is the anode. Is it difficult now? Then amaru නෑ නේද? Then පේනවද how the logic is being developed than just studying. This is the anode and then this is the cathode. Right? This is the anode and this is the cathode. Is it okay up to now? මේවා මතක තියාගන්න ඕනේ නෑ. No need to memorize because we are going to write this later. I just want to make sure that you are understanding it perfectly smoothly යනවා නම් එච්චරයි. හරි? Right. Then now the interesting part. We know the oxidations and reductions. Hurry. I'll use another color. Now, what is oxidation? Now, how do we... wait. Now, how do we identify oxidation and reduction? What is oxidation? Again, I want answers because I'm repeating stuff. What is oxidation? What is oxidation? Quickly, what is oxidation? Removing electrons. What is reduction? Accepting electrons. Oxidation is removing electrons. And reduction is gathering electrons. Now, if you connect a wire to this cell, this rod should remove electrons. This rod should remove electrons. Why? Because simply it's the oxidation. It's the oxidizing terminal. And this should accept those electrons. Does it make sense? These are concepts which we learn in A level, but you can easily use these to understand in O level. I don't know why these things aren't being taught. So this is removing electrons, which is the oxidation. I'll write why we thought like that because this is the oxidation. Maybe make a පිළිවෙලට removing electrons, accepting electrons. See, accept karna mein ganna, gathering electrons, removing electrons. Why? Because this is the oxidation. Why? Because that's the anode. And here it's the reduction. Is it clear? Awulak naha neda, awulak naha neda. Removing, gathering. Hurry, removing, gathering. Okay. Now tell me, right? What is the charge of electron? What is the charge of electron? What is the charge of? It's negative, right? Okay. Now think like this. If someone is removing a negative charge, right? If someone is removing the negative charge, hurry, or repelling, nikang ayin karna, throwing away a negative charge. What should be the charge of this? Why should be this rod repelling or throwing away electrons? Because it doesn't like electrons. Because it doesn't like electrons. If someone likes electrons, then what should be the charge of the terminal? Mama asa electrons, and I am gathering electrons. I am gathering electrons. Not after gathering. Now, in order to be in order to make it easy to gather electrons, what should be my charge? Now, there are a lot of electrons here. I'm godak electrons. I'm looking at a lot of electrons and they are attracting towards me. Then what should be my charge? My charge should be positive, right? Is it clear? See, that's what's happening. See, this rod is easily attracting electrons. Then this should be positive. This rod is throwing away electrons. Why? Because it's negative. It doesn't like electrons. That's how you get it easily. Is it clear? I am easily attracting electrons. If I was negative, can I attract electrons? No, I can't, because electrons don't like to join a negative pole. It likes to join the positive pole, right? So it's joining the positive and it's going away from the negative. Is it clear? Is everything okay? Now we understood what the anode is, what the cathode is, and where the oxidation happens, where the reduction happens, the electron flow, everything. So you can see this is the electron flow. This is the electron flow. And it's obvious that we know, according to the standards, it's just a definition, no need to bother about it. The current flow is the opposite of the electron flow. So simply, if you know the electron flow, you can say the opposite is the current flow. So the electron flow is happening from the anode to the cathode. You can see from anode to the cathode, and the current flow will be happening from cathode to anode. Right? Lazy neda. Acharala amaru පාඩම් කරපුවා. Right? After understanding few easy concepts, now you can easily get those. Now, up to now, we have completed what is anode, what is cathode, where oxidation happens, where reduction happens, and the positive terminal, negative terminal, electron flow and current. We haven't done this part yet, but apart from this and this, all of the parts have been easily completed. Hurry. Now, what we are going to do is we are going to write a note. We are going to write a note. We are going to write everything which we learned, then you will understand. So you can make a note in a way that you will remember for the next few weeks. That's the requirement. Lassana note, the short note or a long note, up to you. Make sure that you will understand once the seminar is over. Hurry. So since you have written the main topic, as a side note, write the activity series. Write this somewhere. Write this somewhere, activity series. Write the activity series somewhere. Write down these five, and write, going down the group, preference to reduce will increase. Going up the group, preference to oxidation will increase. No need to write both, because that's obvious. If the preference to reduction increase, then definitely the preference to oxidation should increase. Doesn't matter. If you want, you can write both, or else if you want, you can write one. Liana kotak gana. Quickly write down it. Write the activity series somewhere. Hurry, write it somewhere. Preference to reduction will increase. Preference to oxidation will increase. Hurry. Okay. Then we start from the beginning. You can draw a sketch. The size of the sketch depends on how you want to construct the note. It's up to you. Hurry, we only have 3 weeks, right? I hope you know how to write a note in a way that you are going to understand. It's up to you. Then we have the zinc electrode. We have the copper electrode. Sorry. We have the zinc electrode. We have the copper electrode. I'll name it zinc here. This is zinc. The side of the electrode doesn't matter, right? You can draw zinc here or zinc here. It doesn't matter. And it's just random. Hurry, zinc here, copper here, and sulfuric here. And wire has been connected like this. We'll use white color for that. This is the wire. Right? And that's it, ne? Right. So from the beginning, draw the sketch. Then I will be logically explaining and getting the answers. You can either write only the answer or else you can logically write how did we get the answer. Is it clear? Balan? Check whether that's clear. Right? Hari? No, wait. Hari. Now from the beginning. From the beginning. What are we going to find first? What are we going to identify first? The cathode and the anode. Cathode and the anode. So what's the explanation? First, as a first point, we are going to find, let's frame it as A. Depends, you can write it as anything. Cathode and anode. No. Not the cathode and. Okay, doesn't matter, cathode and anode. Okay, yes. Cathode and anode, right. Now, how are we going to explain it logically? If you want, you can pay attention once more, or else you can start writing, up to you. You looking at the activity series, we can remember zinc was somewhere here, copper was somewhere here, which means going down the group, preference to reduce will increase. Therefore, this will like to reduce and this will like to oxidize. Is it clear? Going down the group, this will like to reduce, this will like to oxidize. Then what happens? Since this likes to oxidize, this will be the anode, because if oxidation happens anywhere, doesn't matter whether it's electrochemical cells, electrolytic cells, corrosions, whatever, when oxidation happens, that end is known as the anode. Doesn't matter. When reduction happens, that end is known as the cathode. So that should be your answer. Therefore, we can conclude that, what can we conclude? That zinc is the anode. Zinc is the anode and copper is the cathode. Zinc is the anode, copper is the cathode. When you are done, put it on the chat. If you have doubts, you can ask. Huh? Now, after this, you will have a massive advantage over the other students because you know something from A levels, which makes it easy. Don't just write this, huh? Then no point, then it's just the O-level stuff, right? What we understood. Using the activity series, going down the group, preference to reduction increases, preference to oxidation increases, going up the group. Therefore, this will oxidize and this will reduce. Then this is the anode, this is the cathode. Or is it clear? That's how we get the anode and cathode, because now can you understand that this will reduce and this will oxidize because of the preference order? The student who asked the question, can you understand that this will reduce and this will oxidize? Because of the activity series, going down the activity series, preference to reduction will increase. Going up the series, preference to oxidation will increase. Since you know that this will reduce and this will oxidize, according to definition, if a oxidation happens anywhere, that place is known as the anode. If the reduction happens anywhere, that place is known as the cathode. Therefore, simply this is the anode, this is the cathode. That's it. Where are the other elements? That's what you need to understand. You can't exactly say what will. No, now you can't draw a table and write this will reduce, these elements will reduce, these elements will oxidize. That's a relative thing. Looking at the activity series, considering two elements, element which is on top will reduce, oxidize, element on the bottom will reduce. That's it. So you can't say that this will reduce and this will oxidize exactly. It depends on who the partner is, right? It's like comparing your marks. There is no low marks or high marks, right? It's a relative thing. It depends. For one student, if you have 20 marks, if your friend has 2 marks, then you have a very good mark, right? Relatively. But if your friend has 80 marks, then your mark is very low. It's something like that. You can't divide it exactly. Hari, good. We have answers. Good. That's what I want. So what is the difference between electrochemical and electro? Yeah, we'll understand later when we are doing electrolytic tests. Still we haven't done it. Hari. So that's the first part, understanding the anode and the cathode. Then what's the second part? The second part is current flow. Current flow. Before that, electron flow. Electron flow, current flow. Okay, now using the logic which I explained, try to explain from where to where the current flow happens or the electron flow happens. I want the logic, not the answer. Answers is in Komat, you can study and give me, and I want the logic. Now you know this is the anode, this is the cathode. Try to briefly explain how to get the electron flow. Good. Oxidation occurs at zinc. Okay, continue the answer. Good. Good. Others? Everyone try to give me an answer on how to get the electron flow. Not the answer. Not the answer. I want to get the. I want to derive the electron flow. I don't want the answer. Answer you can give anyways. How can you say? Good. 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 Right. Now this is the anode. What does happen in the anode? Oxidation. What is oxidation? Removal of electrons. Then let's remove electrons. Let's remove electrons. See, from the anode, electrons are being removed. Electrons are being removed. What is this? The cathode. What happens at the cathode? Electrons will be accepted. Then let's accept electrons. Then you can easily see the electron flow. You can easily see the electron flow. From where to where is the electron flow? From the anode to cathode. From anode to cathode, or you can make it more complete, from the zinc anode to copper cathode. Electron flow will be happening from zinc anode to copper cathode. Check whether that's easy. Good. There are very good answers. If we put if you put an ammeter here, you will see the current flow. It will give a reading. No, don't involve any battery concept, right? We are not talking about batteries here. That's for electrolytic cells. This is the battery. This is the battery, right? This is the electrochemical cell. Therefore, no more batteries, right? That's a wrong concept. So simply, this is the anode. Electrons will, now you need to understand this concept clearly, because these things will start to get confusing once we start electrolytic cells. Therefore, try to understand these logics perfectly. I told you, I warned you. If you are going to use this method, this will give you a huge advantage when it comes to studying. You will know everything. You need not to worry about anything. But if you don't understand the logic properly, you will get everything wrong. That's why I warned you. I became honest. Hari, that's the issue in A levels. If you are unable to understand logically, then you can't study everything. But for levels, you can. So if you want, you can study. If you prefer that way. But this will give you a huge advantage, right? You have nothing to study now. Hari, right. This is removal of electrons. This is accepting electrons. Therefore, this is the electron flow. And by definition, By definition, if an electron flow is happening from here to here, then this is the current flow. The opposite of that will be the current flow. So you can write from copper cathode. That's just a definition. From copper cathode to zinc anode. This is the definition of a current. Is it clear? That's the definition of the current flow. It's the opposite of electron flow. That you can write current flow is the opposite of electron flow. Therefore, it's the opposite. Right. Right. Then what's the third part? What's the third part? Now this is A, this is B. Then we'll write a C. For the here clear. We'll write a C here. Go C. What's C? Positive and negative terminals. Positive and negative terminals. It's simple. Electrons are negatively charged. Okay, explain. Before I explain. Kianban, how do we know what is positive, what is negative? Do we study? No, we don't study. We logically get it. What's the logic? What's the logic? What's the logic? Good, good. Electrons are negatively charged. Electrons are negatively charged. Therefore, they will be attracted to a positively charged end. Is that clear? Right? Good. This will receive electrons because this is positive. Positive kenara thamai electrons are because electron is negative. Always opposite terminals will be attracted or opposite charges will be attracted. Therefore, these electrons are negative, which will be attracted to the positive end. Then this is positive, this is negative. Do we study that anode is negative? No, never. We don't do that. All our students do that, but we don't do it, right? Anode is negative, we don't know that. We don't study that. We just simply derive it. Right? Then you can say that the cathode is positive, anode is negative. Once you get this practice, you can draw a small graph and within 5 seconds, you can write all of these, believe me. නිකම් මෙහෙම කරද්දි කියන්න පුළුවන්. හරි? So you can write the answer. Electrons will be accepted by a positive end because this is negative and electrons will be repelled by a negative end. Therefore, we know what's positive, what's negative. Right. It's all good. Is everything okay? I'll give you 30 seconds and then we'll move to another part, right? We have few more things to be discussed. We discussed 3 points. Hurry. Okay. Shape neither. Everything is okay, right? Huh. Then what do we have? Here, ne? can't remember. Yeah. Here. Okay. We discussed this. We discussed this. We discussed this. We discussed this. We have to think about observations and we have to think about the reaction part now, right? So we have only reactions. Observations we can do later. Hari. Reactions. So the fourth one, D, is reactions. Fourth one is reactions. Right? Reactions. Now now we know everything regarding this cell. So we have to simply write down the reactions. So you just need to remember how to write reactions. It's not that difficult because all the reactions look the same. Hari, you just need to understand how to write it. For zinc and copper, zinc oxidizes. Now we know that, right? Haven't we written it anywhere? Because this is the anode, you can write it also. This will oxidize. This will reduce, which we understood earlier. Ne? Why? Because this is the anode. Ne? Then zinc will oxidize and copper will reduce. Zinc will oxidize and copper will reduce. So we'll first of all write the oxidation. Where will the oxidation happen? Huh? So yeah, nothing to repeat. I didn't say anything. We simply know that zinc will oxidize and copper will reduce, right? We got it earlier. That's how we got the anode and cathode. In your answer, that should be written, eh? Because zinc was simply considered as the oxidation, and that's why it became the anode. Considering the activity series, zinc was on top, therefore it had the preference to oxidize. Therefore, it became the anode. We haven't written that oxidation reduction part. That's it. Now I wrote it. Right? So when they ask for reactions, they can either say write the oxidation reaction or they can say write what reaction. Instead of saying write the oxidation, they can say write what? Yeah, they can say write the anodic reaction. Both are the same, right? Because in anode, the oxidation will happen. Instead of saying write the reduction reaction, they can say write the cathodic reaction. Both are the same. Alright? Is it clear? Both are the same. Now we can easily write. Now what will oxidize? What oxidizes? Zinc in anode will oxidize. Therefore, zinc will remove electrons. So how will zinc remove electrons? It's like this. Zinc normally prefers to make the zinc 2 plus, which you have to remember. That's just studying. Zinc will remove 2 electrons and make zinc 2 plus. That's how it happens. Because the charge of electron is minus, it will remove 2 electrons, then it will be plus 2. Because the charge here is 0, charge here is minus 2. When you remove 2 minuses, then it will be plus 2. It's easy, right? But we normally don't write the equation like this. Instead, we write it like this. We simply get this to the other side. Then this will be the oxidation. Always in oxidation, electron should be on the right-hand side. No need to memorize it, but that's how it is. It's on this side. This is the oxidation. It has simply removed electrons. You can see electrons are on another side. Metana meya inna electrons tallu karala visit kala dara. No need. Hari. That's the oxidation. The reduction happens to copper. The reduction happens to copper. Hari. Everything is okay, right? The anode is copper, cathode is copper. Yeah. Is it okay up to now? Check whether everything is okay. Under reactions. Is it difficult? Nane, awulak nane. Now we know where the oxidation happens. Then we know what happens, right? Awulak nane. Hurry. Now, what's interesting is now this is the cathode. This is where the reduction happens. This is the anode. This is where the oxidation happens. Since this is the anode and where this is the oxidation place where the oxidation takes place, we took it as zinc oxidizes to zinc 2 plus 2 electrons. That's easy. But now there's an issue. Now can we simply close it saying that copper will reduce? Hurry. Copper will reduce like this. Normally the cation which copper forms is this. Normally the cation which copper forms is this. Hurry. Now here, can you see? Hurry. Right. Erase everything which is unnecessary. Now the reduction. The reduction happens here. The reduction happens here. But you can see if this one wants to reduce, can copper reduce? Can you give me an answer now? This is one small thing which changes from A level to O level because in O levels how a cell looks is different. It's not correct, but for O levels it's fine. Can copper reduce? Why can't copper? Okay, I can see answers saying no. Why can't copper reduce? Now think copper reduce when no, it should reduce because copper is in the cathode and it does reduction. You wrote it without no arguments. But now you are saying then copper can't reduce. Why copper can't reduce? Any answers? Zinc ox. Now even for zinc it worked. Now we got that zinc is oxidizing. It's the anode and zinc goes to zinc 2 plus. It's oxidized. It's fine. But now you are saying all of a sudden copper can't reduce. Why can't copper reduce? What's the difference? Why can't copper reduce? Yeah, I know what reduces, but I'm asking why can't copper reduce? I want the logic. There's an answer saying that hydrogen is present. But if you look at the order, where's the order? Not this one. Do we have the order anyway? Here. There's an answer saying that hydrogen is present, but copper is below hydrogen. Then copper should like to reduce more than hydrogen. Then copper should reduce. Right? So that answer is not correct. Hydrogen is present, not correct. There's answer saying sulfate is present. Sulfate doesn't do anything. It's not correct. Not correct. So hydrogen is higher than copper. Yeah, true. But then copper should reduce because going down the group, the preference to reduction increases, right? Then that's not also correct. Any other answers? Why cannot copper reduce? What's the reason? Because it can only accept electrons, right? But then why can't copper accept electrons? Why can't copper accept it? It's accepting electrons. It's accepting electrons. Then can't copper reduce? If copper reduces, what will happen? Here we have copper. Now pay attention now. This is important. This is copper. This is copper. It accepts electrons. Can't this happen? Can't this happen? Can't this happen? Now for zinc, if you can remove electrons and write like this, why are we having double standards? Can't we do the same for copper and say, okay, electrons have been accepted perfectly fine. That's the cathode. If this is copper, copper accepts electrons and forms copper 2 minus. Why can't that happen? Since your textbook says it can't happen, it's not a logic. What's the logic? Can this happen? Okay, I know. In your textbook, it has said that it said that the hydrogen here will undergo reduction. H plus will undergo. Okay, that might be correct. Then I'm questioning, why can't this happen? Now you know that copper is below hydrogen. Then according to the activity series, copper should be reduced, not hydrogen. Then your textbook is wrong. It says hydrogen reduces. It's not correct because copper should reduce because it's down the it's in, below hydrogen. What's the reason? Okay, looking at your answers, this part might be a little bit complicated. The answer for this is that this doesn't exist. මෙහෙම කෙනෙක් නෑ. Copper can't form a 2 minus. So always remember, right? Always when you are using this logic, make sure, right? Make sure that a metal, this is a metal, right? A metal cannot accept electrons. That's why it doesn't reduce. Now on your textbooks, they haven't given those. They have just said that hydrogen will reduce. You don't know even why, right? And your market I don't know why. Whether they thought that it would be complicated, but it's not. Copper cannot simply accept electrons and make an anion. Metals don't accept electrons. Copper could have accepted electrons if we had copper 2 plus. If we had copper 2 plus, then it could have accepted electrons and formed copper. That's another story. But we don't have. Do we have this? No, we don't have this. Therefore, that doesn't happen. That's the idea. Is it clear? So according to logic, copper is the one who is supposed to reduce, right? Yeah. Any metal doesn't accept electrons. Any metal can't accept electrons and make up an ion. Always it will remove electrons and make cations. Right? According to our logic, copper is below hydrogen. True, we have hydrogen, but copper is below hydrogen. Therefore, copper should reduce. But copper doesn't reduce simply because it can't reduce here. If we had copper 2 plus, then it would have reduced. Hydrogen it would reduce. It won't let hydrogen reduce. But unfortunately, even though copper has the potential, another theory says that copper can't accept electrons. Not only copper, any metal can't accept electrons. It can either remove electrons. That's it. It can only remove electrons. But this is not copper. It can accept electrons because this is copper 2 plus. It can. But this can't. That's the idea. Therefore, we ignore copper. That's what happened. That's what happened. Is that clear? Right? Is that clear? Therefore, copper can't reduce, even though copper has the potential to reduce. Even though copper has the potential to reduce, it can't reduce. Why? If it had to reduce, it should have accepted electrons, but it can't. Then unfortunately, but sadly, copper will have to pass these electrons, the electron supply to someone else because it can't reduce. It can't violate the properties of a metal. Metals won't accept electrons. It can't. Those can't accept electrons, right? Then it will pass away the electrons and it will come here, right? Now, when it comes here, what do we have inside the container? We have H plus and we have sulfate. We simply don't bother about sulfate. We don't know even where it is in the electrochemical series or the activity series. So we are only considering H plus. How do we have H plus and sulfate? Because once you add sulfuric, it will dissociate into H plus and sulfate, right? I think you are aware of it. When you add sulfuric to water, it will dissociate like this, or it will break down like this. This is the reaction. You know this, right? When you add sodium chloride to water, it will break down like this. Do you know this? Do you know this? Same thing. Right? That's the same thing. Right, wait. We'll write the Is it clear? Right. Likewise, here also for sulfuric, it will break down to H plus and sulfate. So we don't care about sulfate. We don't know about it. Even in LLs, we don't bother about it. We only have H plus. Then simply H plus will reduce. Simply H plus will reduce. H plus will reduce by accepting electrons and form hydrogen. Since you have two H's in hydrogen, you need to put a 2 here. Then to balance it, you need to put 2 electrons, right? Because the charge here is 1 plus. On both sides, the charges should be equal. If you want, you can learn to balance those as well. See, 1 plus into 2 is 2 plus. Here it should be 2 minus, then it's 0 on the other side. If not, you can just study it. It's up to you whether how much you are going to logically understand and how much you are going to study depends on your abilities and your preferences. It's up to you. Doesn't matter. Is it clear? That's how you get it. So under cathodic reaction, you can write we have copper and we have H plus. Even though copper is the clear winner according to the activity series, metals can't accept electrons. Therefore, unfortunately, it had to pass the chance to hydrogen. That's why hydrogen reduced. That's why this H plus reduced to hydrogen. That's what happened. Write it down. If you don't want to think about it, you can forget it. Hurry, check whether that's clear. Now we will be repeating the entire process twice, but in a certain pace because we have completed one example. We have to get the final reaction afterwards. Hurry. How did we get hydrogen? Because H plus reduces to hydrogen. That's why. We ignored the ability of copper because simply it can't accept electrons and reduce. Then the next contestant is hydrogen. Not hydrogen. Now, once you add H2SO4 to water, this will dissociate to H plus and sulfate. In the container, you don't have hydrogen. In the container, you have H plus and sulfate. We ignore this. Then we have H plus in the container. It will accept the electrons and then it will reduce to hydrogen. Copper says, I can't unfortunately accept electrons even though I have the ability. If I had copper 2 plus, I could have, but I only have copper. I can't do it. Then can you do me a favor? And he passes the electrons and then H plus will accept it, forming hydrogen. That's what happened. Do we write the physical states in the reactions, whether liquid, solids, and in A levels we write, in O levels, if they have given the physical states in your book, yeah, they have given, so better write. In A levels, you have to definitely write. So it's not difficult, right? Zinc is a solid. All the ions are aqueous. Always, all the ions are aqueous. So when you see a charge, you can just write aqueous. That's it. Electrons has no physical state. This is aqueous. Hydrogen is a gas. That's not difficult thing. Is it clear? Harini? Okay, then how to write the final equation? This is the anodic equation. This is the cathodic equation. Why we ignore sulfate? Because we don't know about sulfate. That's why. Because we are not supposed to learn about sulfate. So for the moment, just ignore. Doesn't matter. Even if we consider sulfate, it's not in the region which we are interested. Therefore, it won't make any difference. That's why we ignore it simply. Right? Why the zinc ions present in the solution doesn't reduce? Zinc ions aren't present in the solution. Where is zinc ions? It's only zinc. We only have zinc. We don't have ions in the solution. It was produced after the oxidation. In the beginning, we didn't have zinc 2 plus, right? We only had zinc. So if you're asking after producing zinc, can they reduce? No, that can't happen. Because then the reaction will be going this like this. So it should go either this way or the other way. That's why. That's not possible. If that was the question. Right. Now you have the anodic reaction and the cathodic reaction. You can simply add these two, then the electrons will be cancelled. Then you will get the final reaction or the cell reaction. Doesn't matter. You can say the cell reaction or the final reaction. It will be zinc solid plus 2H plus. I'm adding this to this. Then these electrons will be cancelled. Then these two will be on the other side, on the right hand side. Zinc 2 plus aqueous plus hydrogen gas. That's it. Right, you can just simply add these two and get the answer for the electrochemical cell. Can you also explain ion extraction with? Not today. That's not under this unit. I'm concerned about whether we can even finish this unit today. Can you repeat how to get final? It's just simply adding these two in a way that the electrons are cancelling. Now, for this reaction, it's easy. On the left-hand side, on the right-hand side, you have 2 electrons. On the left-hand side, you have 2 electrons. So when you simply add it, these two will be cancelled to these two. That's it. Is it important to write the solid and yeah. Write the physical states. Write the physical states. It's important. Is it okay? Sorry? Does it reduce marks? Honestly, I don't know. That's why I said in A levels it will. For O levels, I don't know. I should be honest, ne? But in your resource book, they have given the physical states. So why not writing? It's not difficult, ne? When you have ions, always substances with charges with ions are always aqueous. Copper 2 plus, Al3 plus, H2, H plus, whatever, all are always aqueous, AQ. Then zinc, it's a solid, it's a metal, solid, and hydrogen, it's a gas, is it difficult? No. Normally for units which contains physical chemistry, which are electrochemistry, or the calculation questions. Now, this is not a calculation for you, but this is sort of a calculation after this theory in A levels. For physical units, we normally ask students to write physical states, but if someone has instructed you not to write, then you might not, but I don't think that's the case. No, H2SO4 is just a liquid anyways. It's just dissolved in water. What will happen if you replace zinc with copper and yeah, we actually doing it. Now after zinc, we will be replacing it with iron, and then we will replace copper with iron as well. Afterwards, if you have any doubts, you can ask. If a O-level teacher said that it's not compulsory, then you can check with the O-level teacher, right? Then you can get it confirmed, because honestly, I don't know. I'm not aware about the O-level marking scheme, right? So it's up to you. You can check whether writing the physical states are compulsory. If it is not, no need to write anything. Up to you, right? Okay, thank you for that info. If it is not compulsory, no need to write. So check it, right? Write it down somewhere, and then you can ask your friends and or ask your teacher, O-level teacher, right? Because I am here doing a favor. I am just trying to implement few A-level stuff into your brain, and then it will give you an advantage. But there are things that I don't know about O-level, right? I can't learn all the O-level stuff before doing a seminar. Therefore, I don't know about the marking scheme. So if you simply, I don't know how much marks do they give for your O-level science regarding chemistry. I don't know. Why should I know? I don't know, right? Therefore, I don't know anything about the marking. So these things you can ask from your O-level teacher, right? Or your friend, or just get it confirmed. Right. Then do you understand? Now we have completed one electrochemical cell. Then we'll quickly go and complete few more cells. We have two more cells being given. Then we can easily. Does the concentration of the sulfate ion be constant? Yeah, it won't change. Or sulfates will remain the same. Right? Sulfates will remain the same. Hurry, I'll give you 1 minute. If you have questions, you can ask. If not, we can continue. Now I will ask you to write answers for two more cells on your own. That's what we are going to do here. It's already 9:30. Ne? Ready? I'm just checking whether I have missed anything. No, it's overall sir. Everything is okay, ne? Yeah. Okay. Okay, right. Then the next example, Harini, is everything okay? Now what I want you to do is do the example, the next one on your own. The next example will be always for your syllabus, it's sulfuric here. Only the rods will change, the metal rods will change. Now the previous one was copper and zinc. Now this one is it's iron and copper. Is it? Yeah, it's iron and copper. This is iron. This is iron. This is you can write the second cell. This is copper. Hari. Now listen. I'll tell what you are supposed to do. First, you need to identify what is anode and what is cathode. I'll write it properly. What is anode and what is cathode? What is anode? What is cathode? Doesn't matter. What is anode? What is cathode? Then what did we get previously? What did we get? Go, Amity. First, what is anode? What is cathode? Then second, electron flow, current flow. Second one, electron flow, current flow. Okay, that's about the color. Current flow. Then the next one is positive and negative terminals reactions. Positive, negative terminals. Finally, you need to identify the reactions, which means the cathodic reaction or the reduction, or else the anodic reaction or the oxidation. Right? Is it clear? This is what I am expecting from you. Hari? Okay, quickly. I'll give you 5 minutes. You won't even require 5 minutes for this. And if you have questions, you can ask. Should we write down this question? Yeah, it's not it's just consider this as the theory note, but instead of me giving it, you need to write it. So this is the second cell. We finished the first cell. I explained the entire theory. Now we are not studying anything, right? This is the importance of understanding a logic. Without studying anything, without knowing anything, we are simply using logic to derive what is anode, what is cathode, all of the stuff. You only need to know as a start where Fe and copper exist in the activity series, which we did. Activity series, okay, you need to check where is Fe and where is copper, and then you can start. Looking at Fe and copper, you need to identify what is anode, what is cathode, and then you can continue. Hari? Right. So you need to remember only the activity series. Hari. Yeah. Everything. Under reaction, write the anodic reaction, cathodic reaction, and the final reaction, everything. No, I don't want, no, I want to know what is the positive terminal and what is the negative terminal here. Here I want to know electron is flowing from what anode to what cathode, current flow is from what anode to what cathode. I want here what is anode, what is the anode, what is the cathode, the reactions. Thus, you need to repeat the same structure which we did for the previous one. Previous ago, only the cell has been changed. Okay, I'll give you 5 minutes. When you get the answers one by one, you can put it on the chat. If you get the answer or not, you can put it on the chat. එහෙම දාගෙන යන්න ටක් ගාලා. Any observations? We didn't discuss about observations previously. Ne? Hari, for the moment, write this, then I'll discuss the observations for the previous cell and then we'll discuss it here. It's not difficult. දැන්ටමත් answers එනවා. Good. Students on the live also can send answers to the chat. The YouTube live. Okay. We'll consider the observations later. Right? When you are writing a current flow or the electron flow, you need to write from where to where, not from where it starts. You need to write both ends. From this end to this end. Starting point and the ending point. Both should be written. Okay, good. තියෙනවනේ answers ටික. හොඳයි, yeah, very good. I'll give you one more minute. Okay. ඇතිනේ. I'm getting a lot of answers. Which means everything should be okay, I guess. Right. Now, how are we getting this? Now, you according to the activity series, which you need to remember, Fe is in on top, copper is the bottom, which means this prefers to oxidize and this prefers to reduce. Then Fe is the anode, copper is the cathode. Fe is the anode, copper is the cathode, which is correct for all of your answers on that. This is the anode. This is the cathode. Right? Then, another. Right now, then you know what is anode. You know what is anode. Anode is the place where oxidation happens. So I'll write it here. Anode, oxidation. Cathode. Sorry. This copper is not the cathode. Anode is the cathode. Copper is the cathode. What happens in the cathode? Reduction. Reduction happens. Sorry. Reduction happens, right? Now, what is oxidation? What is oxidation? Removing electrons. Therefore, electrons will be removed here because oxidation is happening in the node. Electrons will be removed. Electrons will be accepted because cathode is electron accepting, right? Then the electron flow is from the iron cathode to the electron is from the iron anode to copper cathode. Now, lazy name, you can easily get the answers, right? Instead of studying, isn't it easy? Then this is the electron flow. This is the electron flow. This is the electron flow. Then the current is the opposite. Current is the opposite. From copper cathode to iron anode. Sorry, from copper cathode to iron anode. Sorry. Then electrons will be accepted to the positive end. Electrons will be removed from the negative end. Therefore, cathode the copper cathode is positive, and then the iron anode is negative. Right? Then for the next part, for the reaction part, I guess these are okay now. If you students on the Zoom, if you miss anything, you can quickly join the YouTube live and go back and check. I think you can go back. You should be able to. Then the reactions. For reactions. So what will oxidize? Fe will oxidize. Then what will be the reactions? Fe will I'll erase everything unnecessary. Right. Fe will oxidize to Fe2 plus 2 electrons. Now you need to memorize that Fe will go to Fe. Don't ask me why is it Fe2 plus, why isn't this Fe1 plus? That's how Fe exists. You need to remember that, right? So Fe goes to Fe2 plus. And then the same problem happens here. Even though according to our logic, copper is supposed to oxidize. Sorry, copper is supposed to reduce. Fe oxidizes, that's okay, that's fine. We have no issues with it. But copper can't reduce because copper doesn't like copper as a metal can't get electrons. If we had copper 2 plus, then it could have reduced, but copper can't do it by itself. Then these electrons need to be passed to hydrogen. Since we have H plus, we have H, since we have sulfuric, we have H plus and sulfate. We simply ignore this. Then the electrons here will be passed to H plus. So it will be common for all three cells. So you can, if you want, you can just remember it or you can just study it. Then H plus will be reduced to hydrogen by accepting these electrons. Right? Then it will be 2 electrons plus 2 H plus. Now you can simply add these two reactions, then you can get the final reaction. So what is this? This is the anodic reaction or the oxidation. What is this? This is the cathodic reaction or the reduction. The second one. I hope this is okay now. Now you can add these two, then the electrons will be cancelled out. Then you can finally. That is okay. Sorry. So for every electrochemical cell, cathodic reaction will be, yeah, in your syllabus, yes. In your syllabus, for all the cells, cathodic reaction is this, because for all the cells we have sulfuric. Now that's not common for all the cells which we have. In your O-level syllabus, yes. That is it. Okay. Then what I want you to do is, now if this is okay, now is it easy? Do you want to remember anything? Is it easy? Do you understand this? Is it okay? Does it have a significant impact? Do you feel confident now? Now you need not to remember anything. You can just start using the logic and then slowly build up all the answers. Is it true, Haridha? Can you confirm whether it's true? Because I want to know whether this is effective. Hari? Good. It's effective, right? Okay, good. Yes, now we have a few more things to be completed. we have few more things to be completed. Now here on your syllabus, they are saying that, yeah, instead of just writing this equation, instead of just writing this equation, now I'll go to this one, the previous one. Now this was the final equation, right? You have this written. Instead of just writing this, they can say, actually we had sulfuric. Actually we had sulfuric. Therefore, we can just add sulfate to this side and make this sulfuric again. That's just a simple thing. But if you're adding sulfuric to this side, you will have to add sulfuric to this side as well. If you just write this as the equation, that's not incorrect, right? But on your syllabus, they have simply given that you can add sulfuric to both sides, then your equation will look like this. H plus 2H plus and sulfate is not sulfuric, you can add sulfate. Then it will look like sulfuric on this side. This and this is sulfuric. Then this and this can be written as zinc sulfate plus hydrogen. Is it true? I added sulfate to both sides to the final reaction of the previous cell and then got this answer. Even this is correct. This is correct. They can't say that this is not correct and not give marks. This is correct, but if you want, you can write it like this. Correct. Here also, if you want, you can do the same. Yeah, it is the single displacement reaction. Good. Here also, you can do the same. I'm just checking whether it has been given on the resource. They haven't specifically said it, but if you want, you can again add sulfate to both sides. Now, this is the I haven't written the final reaction. The final reaction is after adding these, it's Fe plus 2H plus goes to Fe2 plus hydrogen. If you want, you can add sulfate to both sides. Then this will again be sulfuric and this will be FeSO4. Depends. But on the resource book, they haven't given. But if you want, you can. Right. Then observations. Observations aren't difficult. Simply, if you want to get observations, you just need to be aware, is it FeSO4? Yes, it's FeSO4. Now on this side, so no, on this side, when you add sulfate, always sulfate is an ion. Ions cannot be added to this one. This will be added to this one. Then it will be H2SO4. On this side, by adding this one, it will be FeSO4. Right. Right. Here, now if you consider the observations, observation is nothing very complicated. If you know the reactions, if you know the cathodic reaction and the anodic reaction, you can easily say the observations. Now for an example, let's take the previous one. Now what is the cathodic reaction? This is the cathodic reaction. What is the anodic? I'll zoom in these two. This is the oxidation or the anodic reaction or this is the cathodic reaction. Now looking at these two equations, tell me the observation. That's it. Very simple. Looking at these two observations, looking at now you know the reactions. We don't even need the final reaction. No one cares. Only this and this. Tell me the reaction. Tell me the observation. You can see one obvious one. Looking at this, tell me the obvious observation. Yeah, hydrogen forms. Can you see hydrogen? Does it emit telling that I am hydrogen? No, that's not the observation. What's the observation? A gas is formed, so you can see bubbles near the, you can see bubbling near the cathode because it happens near the cathode. A gas bubbles, right? You can see gas bubbles near the cathode. That's one observation. Don't write hydrogen emits. How do you know? Hydrogen emitted hydrogen. You don't know. That's not the observation. That's the conclusion. You can't make mistakes, right? That's the conclusion. That's not the observation. The observation is you can see observe gas bubbles near the cathode because simply it happens near the cathode. It's the cathodic reaction. Okay. That's one observation. Looking at this, tell me the next observation. Looking at this, tell me what's the next observation. Yeah, the next observation is you can see zinc converts to zinc 2 plus. Zinc 2 plus means it's now in the aqueous solution. So slowly zinc will start to what? Dissolve. Which means the zinc rod will start to dissolve slowly. මෙහෙම zinc පූර තියෙනවා නම් ටික ටික එක දියවි දියවි යනවා. It will start to dissolve. Right? That's the next observation because you can see zinc is spending itself. Zinc is reacting. Therefore, the second observation is zinc rod will start to dissolve. That's it. Yeah, I have added sulfate for both sides. Pay attention. Hurry. So the zinc rod will start to dissolve. Near the cathode, air gas bubbles can be observed. So those two are the observations. So is it difficult? No, you can easily write the observations. For this side also, for this one also, you can easily write. You can see gas bubbles on the cathode, near the cathode. And the anode, Fe rod is being dissolved. That's it. Very simple. Neither. It's clear, right? Okay. If this is clear, now we are starting the final one, which I won't do. I will just give you the question. You need to write the answers later, not here. The final cell is. The final cell is. Right. Final cell is again you have sulfuric here. Right? Again you have sulfuric, but rods are the rods are zinc and iron. Did we write it next? The one rod is zinc, one rod is iron. So write the third cell, write down this, and later you can write all the what is anode, what is cathode, electron flow, current flow, what is positive, what is negative, all the reactions and the observations. You can write it later. And you can check with your textbook if you want. Right? Then you will be confident. After the seminar, most probably you will forget all the logics which I taught you. Go through them again, then be confident, be okay with the logics, then try to do this, then you will be okay. Then you will be really confident about your abilities on electrochemical cells. That's it for electrochemical cells. 1/3 of the lesson is done. Is it okay? Is it clear? Yeah, okay. Right. It's 10 o'clock, almost 10 o'clock. So we'll have a small break, right? We'll have a small break and then we'll start in 10 minutes. Then we'll start the electrolysis part. I'll somehow definitely finish the entire unit. But if I have now, I won't continue it. I can continue until 1, 2, but that's not efficient. I know you might even say continue, but that's not efficient. No point. So we'll see if we can definitely finish the entire unit. I'll definitely finish the entire unit. For that, I might take extra time, but for covering the tute, I won't. Then I'll ask you to do the questions later. Hari, we'll see. I just want to give you an idea. So it's 10. We'll start at 10 minutes past 10, right? We'll start at 10 minutes past 10. Before that, write the next topic. Now, electrochemical cells are over. Electrochemical cells are over. That's it for electrochemical cells. Entire theory has been done in a very short but logical way, which makes you uh, which wants a very little amount of memory, right? Mara poddai mataka tiyaganna thiyena, everything else is logic. You can easily get it. You will understand that. You can get it confirmed after doing this example. Hurry, do it on your own later after the seminar. Then write the next topic. The next main topic is electrolysis. Electrolysis. This is the next main topic. The second main topic of the third of the three main topics. And then we'll start it as starting at 10 minutes past 10 a.m. Right? So you can either be on the meeting or else leave, drink some water, eat something and join. Right? But join on time because we'll be starting on time. Same for the YouTube live students. The live won't be stopped. It will be continued. Join on this time. Right? Okay. If you have any questions, you can send it to the YouTube live chat or the Zoom chat. Right? Can hear me, ne? Hari, ne? Okay, I gave you 4 extra minutes and we'll start. I'll just check whether the YouTube live is going. Okay. Okay, then let's start. Hari. Now we have roughly 2 more hours. We have 2 more sections to cover, which is not electrochemistry, which is electrolysis and what's the next one? Corrosion of metals. Sorry. So I want your maximum attention. We continued this for 2 hours. Now we have 2 more hours left. Hari. Right. Now, what is electrolysis? Does anyone know? Now, I'll make the question more easy, simplified. What's the difference between electrolytic cells and electrochemical cells? Now, previously we did normal cells, what we call the battery. It's not actually battery. A combination of electrochemical cells is known as a battery. So you can, but generally you say battery for what we did previously. What's the difference between battery and what we are learning now, the electrolytic cell? Okay, one thing is that we will use a battery here. Okay, the previous one was actually the battery. Here we are using a battery. True. What else? Yeah, in this cell, so the same answer for this cell, we need power. The previous one was the power generator. This one is the power receiver, right? Good. Any answers for why do we need a battery here? Have you ever thought for electrochemical cells, we don't need any power source? That's the power source actually, right? The electrochemical cell is the power source. You can put a bulb and you can try to light it up. It will light the previous one, right? That's the electrochemical cell, right? You need to know the terms when I'm referring to those. Now, what we are doing here is electrolytic cells. For this, but you want a power supply. You need a battery. Why? Have you ever thought why? What might be the reason? Okay, this will be used for electroplating. Yes, that's true. Why is that the reason? Why do we want a power supply for here? For this one? To make ions move, to provide current. Yeah, why do we want current? For the previous one, we didn't want a battery. Again, current was happening, current was flowing. We made electrons move. What's different from the electrochemical cell to this one? That makes a requirement to have a power supply. To make chemical reactions. In the previous one also we had chemical reactions, but we didn't want a power supply. It happened automatically. Why do we want one here? What's the difference? What's the difference? What's the difference? Good. Very good. I don't know whether you have learned these. I don't know whether this is in your O-level syllabus. It might not be. Some reactions are spontaneous. Some reactions are non-spontaneous. What's spontaneous and non-spontaneous? Spontaneous is that the reactions will happen automatically. They prefer to do that reaction. Now, for an example, if you have copper and zinc in a container, right? If you have, let's say you have copper 2 plus and zinc prefers to oxidize to zinc 2 plus and copper will prefer to reduce to copper. So these will automatically happen by nature. That's how it has been built. Those are automatical. Now, if you get a real world example, if this is a mountain, if you keep a ball here, it will automatically fall. Someone can say gravity, but without any interference, it will happen. It will automatically happen by nature. Those reactions are known as spontaneous reactions. That is known as a spontaneous reaction. But if you keep a ball here, will it automatically go up? No, you need to push it. You need to give a force, which means this won't happen automatically, which means this is a non-spontaneous reaction. That's a non-spontaneous reaction. Is that clear? So you have spontaneous reactions and you have non-spontaneous reactions. This is a spontaneous reaction. This is a non-spontaneous reaction. These reactions, all the reactions which we considered under electrochemical cells are spontaneous reactions. All the reactions which we considered under the previous section are spontaneous reactions. Therefore, we did not need any external force. Actually, the spontaneous reactions took place and generated power. The previous one, we generated power. Now, in this part, we are doing the exact opposite, where we are considering reactions which are actually non-spontaneous. These reactions are non-spontaneous, which means we need to give some force, we need to give some energy. Or in other terms, I saw one answer saying, I think that's also not required in your O-level syllabus. We need to create a potential difference. Hari, ඒ terms තේරෙන්නේ නැත්නම් අවුලක් නැහැ. Just get the general idea. In electrochemical cells, the previous section, the reactions were spontaneous, therefore it generated power. It generated එයාම power එක ඇති කරගත්තා. Now, for an example, if we keep a ball here, when it comes down, it has a power, right? It has a kinetic energy. It will go. Mega ignorant down, it has some velocity, it has some kinetic energy. So it generates that energy because it was spontaneous. It easily happens. It smoothly happens. That was the previous section. But in this section, all the reactions which we are considering are non-spontaneous. We need to give some force. අපි බලෙන් තමයි ඒක කරන්න ඕනේ. Right? We need to force them. You might not like to do it, but you have to do it now. Therefore, we need to give the power. අපි බලෙන් ගහලා බැනලා කරන්න ඕනේ. We need to give the energy. That's why, that's the difference of electrolysis and electrochemical cells. That's why we are using a battery here. Is that understood? Is it clear? Is that understood? Confirm? Okay, you understand it, right? So that's the main difference. If you want, you can write it down. You can write it in your own words. What's the difference of electrolysis and the previous section? This is the reactions which are occurring here. All the reactions which are occurring here are non-spontaneous reactions, which doesn't happen automatically. Therefore, we need to give a force. That's why we use a battery. You can write it if you want. Now you have a proper understanding on the difference. Otherwise, you just learn electrolysis and electrochemical cells. Some students even don't know how to differentiate between those two cells. So whenever you see a battery on top of a cell, you can easily say that it is what? A electrolytic cell, because you are using a power generator. You are using a power source, external power source, right? If you see a battery on top of circuit, some circuit like this, everything like this, then this is easily a electrolytic cell. No way, there's no way a electrochemical cell can have a battery here, right? You get it? All right. If you have written down the concept, if you have an idea on what's happening here, then we can start doing theory. Hari. Now I'm going to teach you a logic. Hari, I'm going to teach you a logic. Hari, okay. Now I'm teaching you logic. Hari, I'm teaching you logic to get the reactions of electrolytic cells. Now the topic is electrolysis. The cells are electrolytic cells. Electrolytic cells. Hari. On your syllabus, there are 4 electrolytic cells. Then they expect you to write the anode, the cathode, identify the anodes, cathodes, and write the reactions. The same process which we did for electrochemical cells. But the logics are different. The logics are a lot different. So you need to be able to differentiate. So once you finish both electrochemical cells and electrolytic cells, go through the note later and check whether you can properly differentiate, because if you write the logics for electrochemical cells for electrolysis, then it's wrong, right? There now. Okay, so make sure that you haven't mixed it up. Okay, I'm just checking what we are missing. Okay, we have this. Okay, sure. Hi, then let's continue. All right, let's continue. I'll write one example. This is not according to your order, not according to the order given on your the textbook. I'll use one example which is easy to explain first. Hari, this is one example which is given on your textbook. These are the two rods. One rod is given as carbon, the other one is also given as carbon. For all the examples in your syllabus, always both rods are either carbon or platinum. Doesn't matter whether it's carbon or platinum, both are considered as inert materials, which means those don't react. It doesn't matter whether it's carbon or platinum, both won't react. Therefore, that's easy. And I'll use sodium chloride aqueous here. Sodium chloride aqueous here. Is it clear? Now, we need few things to be clarified before starting to understand the logic. Here and also the battery can be connected. That's later. All right. Oh, come on. Make use karamu then. Hurry. Now, pay careful attention. Hurry. Anode, we have the anode, we have the cathode, we have the electrolyte. And this part, the aqueous solution in the cell, the electrolytic cell is known as the electrolyte, which helps the ion flow. It's known as the electrolyte. This part, the aqueous solution is known as the electrolyte. I'll give you a separate note on the electrolyte later. Just for the moment, understand if you have a aqueous solution here, which enables the electron flow or the ion flow, that is known as the electrolyte. That's it. Hari? Right. Now this is interesting. Now this is different. Now let's always try to compare this theory with the electrochemical cell theory. Then you will understand it properly. Don't get confused. That's why. Hari? Now here, for the electrochemical cell, how did we determine the cathode or the anode? It was determined by the activity series. One on the top of the activity series was anode always. One on the bottom of the activity series was always the cathode. Is it clear? Uda hitiyot anode, yata hitiyot cathode, relatively. That was for the electrochemical series. Now here, for the electrolytic cell, you can't determine the anode and cathode looking at the activity series because that's the natural one. Now we are going to force a reaction which is not happening actually. Therefore, there's no series for it. The anode and cathode will be determined by the battery which is connected to the cell. Hari, if we connect the cell like this, if we connect the cell like this, if we connect the cell like this side is the positive terminal, this side is the negative terminal. Are you aware of it? The longer one is positive, the shorter one is negative. That's the symbol. That's a common one. Now, this battery will determine whether what is anode, what is cathode. So simply if you switch the battery, if you make this positive and this negative, then the cathodes and anodes will also switch. You need to understand that first. Right? Now we'll try to understand how to determine whether what is cathode or what is anode. Hurry. How to determine whether what is cathode or what is anode. Before that, simply you can easily name the terminals. If you connect the positive end to this terminal, then this terminal is known as the positive terminal. It might not make sense because in O levels, it is how it is. In A levels, they will teach how that is given. But for the moment, if this is positive, this is positive. If this is negative, this is negative. So straight away, you know what's the positive terminal, what is the negative terminal. Is it clear? You know what is the positive terminal and what is the negative terminal. And if you have a battery, do you know from where to where the current flows? So looking at this battery, tell me whether the current flow happens anti-clockwise or clockwise. The current flow, not the electron flow. I'm asking for the current flow. Looking at the battery, tell me, that's another lesson in chemistry, in physics actually. Looking at the current battery, I am asking about the current flow. Is it anti-clockwise or is it clockwise? If you want a simplified diagram, is it anti-clockwise or is it clockwise? Yeah, it's positive to negative, right? It's positive to negative. This is positive, this is negative. Then it's like this, right? Sorry. It's anti-clockwise, isn't it? It's not clockwise. It's anti-clockwise, right? Okay. It's anti-clockwise. It's from positive to negative. The current flow, right? Not the electron flow. The current flow is from positive to negative. Now we are going to develop the logic, which means the current flow is going like this, from positive to negative. This is the direction of the current flow. This is the direction of the current flow. Then what is the direction of the electron flow? NaCl is the electrolyte. It's just the liquid. It's just the aqueous solution here. We'll learn about it later. Now, if the current flow is happening like this, if the current flow is happening like this, Hari, how will the electron flow happen? It will be the, is it the same or the opposite? Is it the same or the opposite? It's the opposite. Exactly. It's the opposite. Now, if the current flow is happening like this, the electron flow will happen on the in the other way. Now, are we learning anything new? Are we studying anything new, or are we just using what we know? Everyone knows, every student knows how the current flow happens on a battery. For a battery, it's from positive to negative. That's the current flow, and we know it's the opposite for the electron flow. Therefore, it's from the negative to the positive. Then the electrons will be flowing from the negative end to the positive end. Don't bother about what's happening here. It's just from negative to the positive end. Is this clear? Up to now, is it clear? Up to now, is it clear? It's clear, right? Okay, good. Now, looking at the diagram, tell me, I'll name this as 1, name this as 2. Using the concepts which we know, tell me whether whether what is anode? Is 1 anode or 2 anode? What is anode? Is it 1 or 2? Tell me what is anode. We are not using a single theory, just logics. What is anode? 1 or 2? Okay, good. I can see answers. Good. That's what I want. What is anode? It's 1, right? Is it difficult? Nane, hamon 1 කියලා වෙනවා. හොඳයි. Is it difficult? No, it's not difficult. Why is it 1? Why is 1 anode? Because no, not because it's connected to the positive. I clearly said we are not caring about positive, negative because it's not consistent. We don't know what is positive. We don't study positive is anode, negative. We don't do that. We don't do that here. It's simply, you can see electrons are being what? Removed. Here you can see the electrons are being removed. What's removing electrons? What's removing electron? It's oxidation. What's oxidation? Oxidation is happening where? In the anode. Therefore, this is the anode. That's how this became anode. Here you can see electrons are being accepted. What's that? It's the cathode. That's the reduction. That's the cathode. Is it clear? Now, did we use anything which is inconsistent? Which is different for electrochemical cells and electrolytic cells? No, that's why we are not using that positive negative thing. We don't do that because it's different for the anode in a electrochemical cell. It's negative. Here it's positive. It's a troublesome. No need to memorize that. Hurry. Simply we are using the logic, right? Simply we are using the logic. Right? Yeah, anyway, it will be positive. If you want, you can study because it's always positive for this and always negative for the previous one, but it's easy to get it like this. Then you won't make any mistakes. All right. So this is the idea. By now, we know what end is positive, what end is anode, what end is cathode, and that's it. Right? That's it. Is it clear up to now? Avulak නැද්ද තාම? You know what anode is, what cathode is, and you know that this is electrolyte. We learn about it later. හරිද? හරි. I'll finish the entire part and then we'll step by step construct the node, right? Don't bother about it. Once you construct the node, you will have all the knowledge. Sorry. You just need to make sure that you're understanding the step which I am teaching. No need to memorize the previous one. Sorry. So what direction does the electrons move? So I have written it. This is the direction from anode to cathode. Metin direction. This is the direction. Sorry. Right. Then what's happening? Then the reactions. The reactions. Now for the reactions. For the anode, now these things won't be taught in all of us, but I am willing to teach you these, right? I'm willing to teach you these. First, we are considering the anodic reaction. First, we are considering the cathodic reaction. Reaction in the cathode, which is happening near the cathode. The cathodic reaction. What happens in the cathode? The reduction. It's always the reduction. It doesn't matter what cell. It's always a reduction. Near the cathode, reduction happens. Right. Now, Hari. Then, for the cathode, if they ask us to write the cathodic reaction, it's always simply looking at what's in the electrolyte. It's only what's in the electrolyte. We are not even bothering to look at the rods. Rods වල මොනවද තියෙන්නේ කියලා අපි බලන්නේවත් නැහැ. We are not considering the rod. We are only looking at the electrolyte. Now, what do we have? What ions do we have in the electrolyte? Now, we are not considering the compound. We are considering it ion-wise. Tell me quickly, inside this electrolyte, what ions do we have? What ions do we have? Once you add sodium chloride to water, you will have sodium plus. Good. Cl minus. Okay. What else? What else? Yes. Since we have water inside this, because this is aqueous, which means we have water, we have H plus in water and OH minus in water. Therefore, we have 4 ions which we need to consider. Is it clear? We have 4 ions which we need to consider. Hari. Then, මෙහෙමයි වෙන්නේ. මේ බලන්න. Cathode is the reduction. Cathode is the reduction. What is reducing? Accepting electrons. What is reducing? Accepting electrons. According to your understanding, just think, this is a very simple question. Will positive ions like electrons more or will negative ions like electrons more? Will it be positive ions or will it be negative ions? It's positive, right? Positive ions will like electrons more because they don't have it. අපිට නැති දෙයනේ අපි ආස, right? We like what we don't have. හරිද? Positive ions don't have electrons a lot. They have a deficit of electrons. That's why they are positive. They are like electrons. Then what's reduction? Accepting electrons. Therefore, these are the two contestants which are interested about reducing. So simply we ignore these two. So always consider the positive ions. Positive ions. The positive ions are the ones which are interested in reducing. Nothing new, huh? Nothing new. You just need to make a neat note later. That's it. The positive ions. Now we have two positive ions. Now what are the contestants? Sodium plus and H plus. Now these are the two contestants which are trying to reduce. Tell me what will reduce. Now I won't guide you. I won't help you. Use whatever the theory you know and tell me if you have sodium plus and H plus, what will reduce? Is it H plus or is it sodium plus? And I want why. Not just the answer. I want the explanation. If you have sodium plus and H plus, what will reduce? Good. Others? What will reduce? Anita? Good. It's H plus, right? Why? Because we know if we consider the activity series, going down the activity series, the preference to reduction will increase. Some students had got it mixed up or confused. Simply, hydrogen is below sodium, therefore it will try to reduce. It likes to reduce, it prefers to reduce. So is it something new? No, we know that. Then H plus will reduce to H2. H plus will reduce to H2. So this will be the reaction. I'll write it properly. This is the cathodic reaction. H plus will accept electrons and reduce to hydrogen, which is this. This is the cathodic reaction. This is the cathodic reaction. Now the anodic part, the cathodic part is done. Simply we only look at what is on the electrolyte, and also we only consider the positive ions, and then you can use the reactivity series or the activity series and get the answer easily. Hari. For the anodic reaction or the oxidation for the anodic reaction or the oxidation. Once you get used to this, once we write all the examples, you will be okay with it, right? This will be very easy. How to find anode? Okay, I'll repeat the entire thing later. Hurry. For the anodic reaction, what you are supposed to do is, first you need to look at the metal rod. That's the proper theory. Hurry. First, the first priority will be given to the anode. If the anode can oxidize, then that will oxidize. But fortunately, in your syllabus, all the anodes are either carbon or either platinum. I checked all the examples. All the examples are either carbon or either platinum. Therefore, that theory can be ignored. So what's the first theory? Considering the anodic reaction, the first theory is actually that the anode rod will oxidize if possible. No, not for cathode. Cathode, we only care about this one. That's the theory. But for anode, we care about the anodic rod. But fortunately, for all the examples in all levels, they have excluded that theory by making all the anodes either carbon or platinum. Carbon and platinum are considered to be inert, which means they won't react. Then that first theory can be ignored. Then again, if you ignore the first theory, again, you have to look at the electrolyte. So simply for the cathode and anode, both we will be only looking at the electrolyte. Then I'm asking the same question which I asked here, right? Now, what is anodic reaction? What is anode? What is anode doing? Oxidizing. Oxidizing means removing electrons. Who will remove electrons? Positive ions or negative ions? Who will remove electrons? Positive ions or negative ions? Who will remove electrons? Is it positive or negative ions? Negative ions, right? Why? Because negative ion doesn't want electrons. It has a lot of electrons. Positive ions like electrons. That's why positive ions accepted electrons, but negative ions doesn't like electrons. It has we can give, right? If you have a lot of money, if you have a lot of food, we can give a little bit. Same thing for negative ions. Negative ions have a lot of electrons. That's why they are negative. So they try to give a little bit of that. Therefore, anodic reaction or the oxidation is giving electrons, lending electrons, which is done by the negative ions. So for this one, you need to consider the negative ions. That's not the proper theory, but for all levels, since we are ignoring this, we are only considering the negative ions which are on. So what are the negative ions? It's Cl minus and OH minus. It's Cl minus and OH minus. Hurry, it's Cl minus and OH minus. Hurry. In your syllabus, always the anodic reaction will be, right? Always the anodic reaction. I'm just amending the theory, making it suitable for all levels, right? In your syllabus, according to your syllabus, always the anodic reaction will be either Cl minus or OH minus oxidizing. Right? Therefore, if you have both, give the priority to Cl minus. If you have one, then that will be oxidizing. That's just a theory for the moment. That's not the proper theory. But if you have, there's a theory to explain why Cl minus gets the priority, but that's not necessary here. So if you have, so for all levels, always the anodic reaction will be either OH minus or Cl minus. Always for all the cells. If you have both, give the priority to Cl minus. So I'll write it like this. 1 Cl minus, 2 OH minus. Both won't happen, no? This is the priority order. One will happen, only the first one will happen. If you have both, the first one will happen. If you have only the first one, then it will happen. If you have the second one, then that will happen. Hari? Is it clear? So that's the entire part of electrolytic cells, apart from the applications. Now we'll try to make a proper short note, and then I'll give you 3 more examples. Then you can do it with me. Hari? Then we can finish this part. Is it clear? Check whether it's clear. Hurry. Then write the topic electrolytic cells. Write the topic electrolytic cells. For these cells, we can actually give names. Write the topic electrolytic cells. Yeah, I'll explain how to express the anodic reaction. Everything I'll explain. Okay, how to write this, ne? We'll write it later. We'll write the anodic reaction after with the note. And what they want to check? Now the names of the cells. Okay, so this is electrolysis of. So write the first one under electrolytic cells, the first topic. You can write electrolytic cells as the topic. Right? For this one also, you can write observations. You can see. We'll discuss the observations later. You can write a subtopic electrolytic cells. The main topic is electrolysis. This is electrolytic. Under this subtopic, you can write one or Roman number 1 and write. Tut is given on the group. I'm not sure whether we have time to discuss it. That's what I said before the interval. Hurry. Put Roman number 1 and write. Put Roman number 1 and write. Put Roman number 1 and write. Electrolysis of aqueous sodium chloride. You can see this is sodium chloride. Electrolysis of aqueous sodium chloride. Electrolysis of aqueous sodium chloride. Right? Electrolysis of aqueous sodium chloride. Right? Electrolysis of aqueous sodium chloride. Good. That's the topic. Under that, you can draw a small sketch. We'll start from the beginning. Under Roman number 1, draw a clear diagram because we have to write a lot. This will be your note afterwards. That's why. This is sodium chloride aqueous. The rod is carbon. And then a battery has been connected. Everyone draw the battery like this. If you switch the battery, then everything will be switched. That's not incorrect. That's correct. But then you will get confused because I am writing cathode this side. Then, but for you, it will be anode. That's why. So simply the direction of the battery will determine what is cathode and what is anode. Is it clear? I'll make it a little bit more shorter, this one, to make it obvious. So this is the positive end, this is the negative end. Within 10 more minutes, we'll be finishing this part as well, the theory part. Hurry. Okay, shall we continue? Now, what's the first? Now you can write a note with me. Hurry, I expect you to write a note with me because we have 3 more examples where you can do on your own. Hurry. Then, the first thing we need to identify the positive and negative terminals. Positive and negative terminals. It's easy. The first one is identifying the positive and negative terminals. A. Positive and negative terminals. How are we identifying the positive and negative terminals? Quickly put it on the chat. Chat. How to identify the negative and positive terminals? Yes, the battery connection. Here you can see that this side is positive, this side is negative. This side is positive, this side is negative. Therefore, simply this side is positive, this side is negative. Okay, write that down. Simply looking at the battery, the positive side of the battery will be the positive side of the electrolytic cell. The negative side of the battery will be the negative side of the electrolytic cell. Have you seen a jump start? Have you seen a jump start? අර කාර් එකේ බැටරි එක බැස්සම මෙන්න බැටරි gets මොකක්ද ඒ කියන්නේ මම දන්නේ නැහැ කියන ටර්ම් එක. Then අර ජැක් එකක් ගහලා you give the jump to the car from another car. Have you seen it? So do you know what I am saying? A jump start. That's what's happening here. So this is the car with no power, which needs the potential difference. This is the car with the potential which has a good battery. This is the good battery. This is the battery with no power. Then we are giving power from here to here. So if you check that, it will be positive to positive, negative to negative. Because it's giving power from here to here. Some students think that it's positive to negative. Then there will be a current flow. To make a current flow, this should be a proper battery. But this is not a battery now. It's not working. This is something like a battery which is not working. We need to give power. Then it's positive to positive, negative to negative. If it is possible, check how a jump start is being given. You know what I am saying. Right, good. Then the first one is done. So it's positive to positive, negative to negative. So you can't say carbon electrode is positive because both are carbon. This is positive, this is negative. That's it. Then anode and cathode. No, sorry, not anode and cathode. The current, electron flow, current flow. Electron flow, current flow. Always this order should not be maintained, right? Once you get used to this, you can start from whatever the order you prefer. I am just continuing order, but which I prefer. Right? First current flow, not electron flow. First current flow. Current flow. Then electron flow. How to get the current flow? It's from considering the battery. Considering the battery, it's from the positive side to the negative side. Therefore, this will be the current flow. It's from the positive to negative side of the battery, not the cell, not the electrolytic cell. Positive to negative side of the battery or the power source. This one, positive to negative side. So this is the positive, this is the negative. Clearly write those down. Hari, that's the electron flow. Sorry, the current flow. Hari, the current flow is actually anti-clockwise. This is anti-clockwise. Then the electron flow is the opposite of that. Opposite of that. It's the opposite, which is clockwise. Electrons will be flowing like this. So I'll write it. This is the electron flow. Nothing new. Nothing new. Huh? Everyone knows how the current flow happens. Electron flow is the opposite of that. Hari, shape ne? Okay, good. Then third one. What's the third one? The third one is the cathode and anode. Cathode and anode. Now it's easy to get the cathode and anode. How to get the cathode and anode? Here you can see electrons are being removed. Removal of electrons, which is oxidation, which is happening on the anode. This is the anode. You can write it, just don't write this is anode, write why. Electrons are being removed, which is oxidation, which is anode. Electrons are being accepted, which is reduction, which is cathode. Check whether that's okay. අවුලක් නෑ නේ ප්‍රශ්න අහන්න ගැන තේරෙනවද නේ? Finally, we have to write the reactions. මෙතනට ගන්න I'll give you 30 seconds more. Hari? Okay. Finally, the reactions. How about reactions? First, we are considering the cathodic reaction. What did I say? Now we need to divide this electrolyte into ions. What are the ions? You can write sodium plus, Cl minus. Since we have water, it's H plus and OH minus. These are the ions in water. These are the ions in the electrolyte. Hari? These are the ions in the electrolyte. Considering the cathodic reaction, what is cathodic reaction? Cathodic reaction is reactions, the cathodic reaction or the reduction. Reduction is happening in the cathode. Ne? So it's the reduction. Hari? Then you can say either the cathodic reaction or the reduction. Hari? Then what is reduction? Accepting electrons. Is it accepting electrons? Yes, it's accepting electrons. Then who likes to accept electrons? The person who doesn't have electrons, which is the positive ions. We are only considering the positive ions. See, can you see how am I writing the note? It's the positive ions. Now, what are the positive ions? Sodium plus and H plus. Out of these two, who is the winner? Out of these two, who is the winner? This one. Why? Because it is it's in the bottom considered to sodium in the activity series. Going down the group, going down the activity series, the preference to reduce will increase. Therefore, hydrogen will be the winner. This will be the winner. Therefore, the reaction will be H plus reducing to hydrogen. Check whether this is understood. Check whether this is understood. If not, let me know. This is the cathodic reaction. You can do the same for and the anode. I'll write it. You can copy this for the cathode. For anode, for the anodic reaction, what is the anodic reaction? What happens? The oxidation. The oxidation happens. Then oxidation means removing electrons. Who will remove electrons? Minus ions. Why? Because they don't like electrons. Who are the minus ions in this container? It's Cl minus and OH minus. So simply give the priority to Cl minus. This is priority. If you have both, this will oxidize. If you have both, this will oxidize. Hari, that's a theory. That's a theory for all levels. Hari. Then how to write the oxidation reaction? It's simple. Cl minus will oxidize to Cl2. You can balance it, put a 2, then you have 2 minus here, then you can put 2 electrons to this side. If it's not understood, you can ask, sorry. Or else you can just simply remember the equation. Cl minus will oxidize to Cl2. Since we have 2 here, you have to put a 2 here. Then the charge on this side is -1 to 2 is -2. To balance it, you need to put 2 electrons to the other side. So this is the anodic reaction. If you want to get the total reaction, you can simply add these two and get the total reaction. Hari. Karaganna bala. And if you have OH minus, if you want to write the oxidation reaction for OH minus, we'll discuss it when it comes. In another cell, we will have to write that, then we'll write it. Hari. For the moment, ignore it. Okay, under reactions, which is the fourth one, I think, the fourth part. Cathodic reaction, positive ions considering winner. Anodic reaction, negative ions considering. We are not talking about any winners. We are not applying the activity series because we don't know anything about these for the activity series. We'll just write a priority. That's it. දාගන්න බලන්න. Is there any logic to find which ion has more potential to oxidize? Yeah, it actually has a logic. It's known as I can't remember. I can't remember the term, but definitely there's a logic to determine whether Cl minus or OH minus oxidizes. But for the moment, for all levels, no need. You can just remember. Always you will get these two. Out of those two, Cl minus gets the priority. Right? So the closest logic is if you have two ions, for these two, the oxidizing potential is almost equal. Therefore, the one with the higher concentration will oxidize. In this case, Cl minus concentration is higher because in water we have a very little amount of OH minus. But if you add like two drops of salt, then the Cl minus concentration will be higher enough to exceed the OH minus concentration. Therefore, Cl minus will oxidize. I'm just explaining, no need to understand since there's a question. Right? Then you can ask why the concentration determines the potential of oxidation. Then that's another concept. ඒක තව තියෙනවා high voltage concepts. එහෙම තියෙනවා එක එක ඒවා, but not necessary here. Even in A levels, that level won't be discussed. Right? Simply this is enough. Right, then that's it. So you can write the final equation at these two reactions. Then you will get 2H plus. Sorry. You will get 2H plus 2Cl minus goes to these electrons will be cancelled to this one, H2 plus Cl2. H2 plus Cl2. Looking at this reaction and this reaction, you can get the assumptions. Oh, sorry, the observations. Right, you can get the observations. Hydrogen will be emitted or gas bubbles will be emitted or be shown near the cathode. Chlorine will be emitted near the anode or else gas bubbles. Depends. When an element and radical come, element gets. We don't have radicals. What's radical? These are ions. These are ions, not radicals. OH minus is also an ion, not a radical. In all levels, do we have radicals? I don't know. What are the observations? That's what I said. Near the cathode, you can see gas bubbles for hydrogen. Near the anode, you can see gas bubbles for chlorine. And later, this reaction will be modified. Then you will find another observation as well. We'll do that later. Hari. Is this clear? Is everything clear? Is everything clear? From current flow to identifying the cathode, then everything anode, cathode, the positive, negative terminals, is everything clear? Everything derived from logic without remember anything? Harida? No need to add anything. You can just continue like this. So this reaction will be changed later. I'll explain why. Apart from that, we are done. Hari? Nothing new, right? Everything which we know knew. Activity series, we wanted the activity series a little bit, and we wanted to know that the current flow is happening from positive to negative end of a battery, that we knew. Apart from that, everything is just logic. You just need to remember how the logic flows. By doing 2 to 3 examples, you will definitely remember it. That's it. Lazy. Now I'll give you the next another example. Try to do it. If you can do it, I'll give the remaining 2 as homework. The second one, let's write this one, the same one, something very similar. Put as a topic Roman number 2. I don't know whether it's Roman number 2 or normal numbers 2. You can, I don't know your numbering, use anything. Put 2 and write the second cell. Electrolyzing aqueous copper sulfate. Electrolyzing aqueous copper sulfate. Electrolyzing aqueous copper sulfate. Hurry. Electrolyzing physical states in the final reaction. Yeah. So the same thing. If it is iron, it's aqueous always. Hydrogen is a gas, chlorine is a gas. Nothing new. All right. Are electrolyzing aqueous copper sulfate, and the electrodes are carbon or platinum. Doesn't matter. You can either write carbon or you can either write platinum. I write carbon. This one is copper sulfate aqueous. Right. First start. Identify the positive and negative terminal. The same things which we did previously. Identify the positive and negative terminal. Then identify the current flow. Then the electron flow. Then identify the anode and cathode. finally identify the reactions. To make things interesting, to make things interesting, what I'm going to do is I'll change the order of the battery. This time I'll make this end positive and this end negative. Then you need to be able to apply the theory. The theory remains the same, but now you can't just copy paste the answers. I have reversed the order. It's stuck. Right. Okay. Quickly send me the answers. So this is the positive terminal. This is the negative terminal. Now, quickly do and send me the answers. 2 minutes. 2 minutes is enough. Send the answers to the chat quickly. Send the answers quickly. Okay, good. Answers are running. Good. So it seems that everyone is okay with it. We'll quickly go. Since this is the positive end, this is the positive end, this is the negative end. Very simple. So this is positive, this is negative. Done. Current flow is from positive to negative. So current flow is anti-clockwise now. Sorry, clockwise. This is the current flow. Therefore, the electron flow will be the opposite of that. The electron flow will be the opposite of that. Let's say this. Ne? Electron flow will be this. That's correct. Then you can see that electrons are emitting. Electrons have been removed from this end, which is oxidation. Therefore, this is the anode. This is the anode, which is where the oxidation happens. Electrons are being accepted, which makes this the cathode. Which makes this the cathode, and electrons have been accepted. Therefore, this is the reduction. It's very easy, right? Now it should be really easy. Good. Then you can write down the reactions. Again, we are not considering the rods because both are carbon, both are inert. We need to break down these electrolyte into few parts. Copper sulfate contains copper 2 plus, sulfate H plus and OH minus. In water, it contains H plus and OH minus. Considering the anode, considering the anode contains anode does oxidation, right? Anode does oxidation. Oxidation happens. Okay, we'll start from the cathode, as I said previously. We'll start from the cathode. Cathode. What is cathode? Removing electrons. We are only interested about negative ions because electrons will be removed by negative ions. Negative ions. Negative ions. What are the negative ions? This and this. We are only considering what? Sorry, what's this? Cathode. No, where are we? Cathode is what? Cathode does what? Oh, reduction. Sorry, cathode does reduction. What is reduction? Accepting electrons. Cathode is accepting electrons, which means positive ions should be considered. Why? Positive ions will actually accept electrons. Is it clear? Positive ions will actually accept electrons. Therefore, are cathodes accepting electrons, which will be done by the positive ions. So we have this one. We have two positive ions, which is copper 2 plus and which is H plus. Who is the winner? Who is the winner? Is it copper 2 plus or H plus? Who is the winner? Who is the winner? Yeah, it's copper 2 plus. The winner is copper 2 plus. Why is the winner? Because we are considering about the reduction. Cathode is the reduction. Here it's the reduction. So going down the electrochemical series or the activity series, the preference to reduce will increase. So copper is below hydrogen. Therefore, copper will have the higher preference to reduce. Then the reaction will be copper 2 plus reducing to copper. See, now you can see, right? Copper 2 plus can actually reduce, but copper can't. Copper can't accept electrons, but copper 2 plus can. I said previously when we were doing electrochemical cells. Right. This is clear, right? Yeah. Copper finally got the chance to reduce. Right? Good. That's the cathode. And that's the cathode. Then what's the anode? Considering the anode. Anode is what? Anode is removing electrons. So oxidizing or removing electrons. The electrons will be removed by negative ions because negative ions have a lot of electrons. Therefore, it can easily be removed. Then we have OH minus and sulfate. As I said, we won't consider sulfate. We only are interested about OH minus and Cl minus. The priority will be given to Cl minus, but here we only have OH minus. Therefore, it will be OH minus. We won't consider Cl minus, sorry, sulfate. Then the reaction will be OH minus will be oxidized to oxygen. This is the reaction, which I didn't give you previously. This is the reaction. OH minus will be oxidized to oxygen. Now, how am I going to balance this? On this side, I can see two oxygens. Therefore, I'll make this two. Then I have two oxygens. But on this side, I have two hydrogens. Therefore, I'll add two hydrogens. I have to add it like this. Now, for this part, you can either study the reaction or you can understand how to get the answer. Doesn't matter. Because we have done a lot without studying. So you can, if you want, you can study this. It doesn't matter. But even this, you can understand how to balance. Hari, you have two oxygens, put a 2 here. You have two hydrogens, put a 2H plus here. Now check the charges. What's the charge on this side? The charge on this side is -2. -1 to 2 is -2. Here the charge is 0 for oxygen. Charge for H plus is +2. The difference is 4. Therefore, you need to add 4 electrons. Add 4 electrons. That's how the reaction is being balanced. Okay, and this one will be changed a little bit later, but for the moment, this is the reaction. This is the reaction. Ready? Check whether everything is okay from top to bottom. From identifying, oops. Identifying the cathode, anode, reactions, terminals, everything. Is everything okay? Final reaction we will write after making a small change in the reactions, right? Apart from that, is everything okay? හැමදේම හරිද? Hmm? Is it understood? Can you show the anodic reaction? Okay, sure. These are okay, right? Then this is the cathodic reaction and the anodic reaction. Simply, we had the options, negative ions, sulfate, and OH minus. We only are interested about OH minus and Cl minus. We didn't have Cl minus, therefore, this gets the chance. If we had Cl minus, we need to give priority to Cl minus. Is it clear? Clear, right? හොඳයි. Now it's not difficult, is it? It's not difficult. Hari? Okay, good. Now we are going to make a small change. Pay attention. Hari, pay attention. For the previous one also, we are going to make the exact same change. Hari, for the previous one also, we are going to make the exact same change. Here, actually, in this case, even though we can, to make our reaction writing process easy, we write water as H plus and OH minus, which is not correct. In your textbook, this hasn't been explained. They have just made the change, but I'll explain you why. According to theory, Hari, in water, the H plus and OH minus concentration is very low. It's very low. It's something like this: 10 to the power -7, which is 0.00000001. The H plus and OH minus concentration is water is this small. Then in a situation where we have water, instead of writing water for the equation, writing H plus and OH minus is actually not the correct representation because we don't have H plus and OH minus. We have a very small amount. It can even be neglected. But to make the reaction writing process easy and to understand the theory, we did break down it to H plus and OH minus and then determine what reduces, what reacts. Because if we didn't break it down, it's difficult to write the reactions. But once we write the reaction, we need to change the reaction in a way that this H plus should be converted to water simply because H plus is not the prominent character in the container, which is water. If you don't understand that concept, simply remember, divide this into H plus and OH minus. Once you write the equation, if you have H plus or OH minus in the reaction, make sure you convert it back to water. How are we converting it back to water? If you want to convert this equation, it's very easy, right? Pay attention. Now here, you have two H pluses. If you have one H plus, how can you convert it to water by adding what? If you have one H plus, how can you convert it? By adding what? මොකක්ද add කරන්න ඕනේ? Yeah, you can add OH minus. Since you have two H pluses, I am going to add two OH minuses. Can you only add two H minus to this side? No, you need to add it to the other side as well. You have to do the same change. Right. Hari? I'll just, for the moment, erase the other reactions because we have written these previously. So what I did was I need to transform this to water. Therefore, I added OH minus. Now what happens? H plus plus OH minus is water. Since we have two, it's two water. Nothing happened to the electron part. H plus H2, nothing happened. We added this one, 2OH minus. So this will be the actual cathodic reaction for the previous one. For the previous cell, we, instead of writing like this, since the actual character is water, we are transforming this H plus into water by adding OH minuses to the both sides. That's what's happening. Sorry. Check whether that's understood. So for this one, you can write another example, another observation. If you add phenolphthalein to the container, phenolphthalein to the cell, this is the cathodic reaction, right? This is the cathodic reaction. This is not the analytic. This is the cathodic reaction. Near the cathode, phenolphthalein will show pink color because it's basic now. You can see some basicity has occurred. Here again, you can write observations using your knowledge. Check whether that's okay. That's for the previous one. හරිද? For the exam, you need to write this. This is not correct. You need to write this for the exam. When you are even getting the final reaction, you need to add this to the anodic reaction. I have erased the anodic reaction. You need to add this to the anodic reaction. Then this should be water on this side and there should be OH minus on the other side. This is the proper reaction. For the next cell also, you need to do the same change. Can you see? Here, we have written OH minus. We have written OH minus, which is not correct. We had water. Don't bother about this side. That's a product. We are only bothered about this side. We can only control this side, the reactants. We thought that OH minus is reacting, but actually OH minus is not the prominent character. It is water. You need to make this OH minus water by again adding two H pluses. For this one, you need to add two H pluses. You can't just add two H pluses. You need to add two H pluses to this side as well. I better write in white color. Then this side will be two water. This side will be two water. The other side will be O2 plus 4H plus 4E. This is how you actually get that equation. Most of the students get confused because the textbooks just say to write this. This is the equation. This is the correct one. When you are getting the final reaction, you need to add this to this. So you can see by directly adding the electrons will be cancelled out. So you need to multiply this equation by 2. Then there will be 4 electrons. Then you can add that to that. Then the 4 electrons will be cancelled out. That's easy. Hari? Right. Then that's it for this part. Then I'll give you two more cells which you can do as homework. Third cell, the third cell is, right, put Roman number 3 and write the third cell. Third cell. Electrolyzing. Overall reaction the overall reaction is simply adding these two, but multiplying this by 2 because this needs to be 4 electrons. Multiply this by 2 and then add this to this one. Then you can get the overall reaction. All right. The third one is write down electrolyzing yeah, okay. Electrolyzing electrolyzing fused sodium chloride. Electrolyzing fused sodium chloride. What is fused sodium chloride? What is fused sodium chloride? What's another term for fused? Yeah, molten, not, yeah, it's melted, molten. Which means you, now the difference between aqueous sodium, this is aqueous sodium chloride. Fused sodium chloride is this, sodium chloride liquid. So if you simply dissolve sodium chloride in water, that's sodium chloride aqueous. That contains water and sodium chloride both. But if you just heat sodium chlorides until it passes the melting point and it becomes a liquid sodium chloride, then even though it looks like a liquid, it doesn't have water. It's just sodium chloride. It's known as the fused sodium chloride or the molten sodium chloride. Is it clear? Hari. Therefore, now we are actually electrolyzing sodium chloride liquid. Here, these are both carbon. I'll take this side as positive, this side as negative. Now you can write the terminals, positive, negative, you can write. You can write the directions of current and electron flow. And then you can identify the anode and cathode. I won't do those. Only thing I am caring about is the reaction. The reactions. Hari, others you can do. Hari, you can keep space and then you can do. The only difference here is you can see what do we have inside the container. What do we have inside the container? What ions do we have? What ions do we have? Yeah, we only have sodium plus and Cl minus. We don't have H plus and OH minus because we don't have water. So you need to take this into consideration when you are writing the oxidation reactions and the reductions. That's it. So this will be the only positive ion. Therefore, this will be reducing. This will be the only negative ion. Therefore, this will be the oxidation. This will be oxidizing. Hari, that you can figure out. I'll give you 1 minute. Keep the relevant space. Then you can write the fourth subtopic that you can do by in your own. Hari, that's the only thing which changes. We did the aqueous sodium chloride. The only difference between aqueous sodium chloride and this is that this doesn't contain H plus and OH minus. This doesn't contain water simply. That's it. You need to take that into consideration when writing equations. That's it. Everything is same. Now, since you know the logic, no need to memorize, just identify the difference. Right? Here, is it okay? Hurry. So you can write down the reactions. Sorry. And always, if you have doubts, you can simply check whether your reactions are correct or whether your observations are correct on the textbook. All the answers are on the textbook, but the logics aren't there. They have just said this is this, then students have to study. But we know the logics after writing. If you want to check, you can either send it to me or else you can simply check your textbook. All the answers are there. This is the third one, and then we'll continue. We'll write the fourth one again as homework. The fourth one. What's the fourth one? The fourth one, write the fourth one. Electrolyzing. 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 Acidulated water. Electrolyzing acidulated water. Acidulated water. Electrolyzing acidulated water. Again, you can use. Now the experiment setup is different, which is given on your textbook. But for the moment, I'll just draw the simple setup. It's different. You can check your resource book. It's different the setup, but same concept. Nothing will change. Again, depending on the, did I give you a battery? Okay, I have given it. Depending on the battery directions, positive and negative, you can determine what is positive, what is negative, current flow, electron flow, cathode, anode, all are same and common. You can use the concept and get it. Again, what I am interested about is the reaction. Now, what is acidulated? Does anyone know what is acidulated? What is acidulated? What is acidulated? Meaning? Yeah, it's simply having some sort of a acid containing in water. Acid mixed is the meaning of acidulated, right? Let's take normally let's take sulfuric, right? Let's take sulfuric as the acid which is containing here. Therefore, inside this you have H plus sulfate from the acid. From the acid you have these two, and since we have water, we have again H plus and OH minus. Sorry, we have H plus and OH minus. Is it clear? Hari. Now, මේ බලන්න. There's a small thing you need to understand here. For the anodic reaction, okay, you can do it on your own, but I'll just show something, then you can do it later. The anodic reaction will be this, right? Because you can see anodic reaction is for anions. Sorry, anodic reactions is removing electrons. So who will remove electrons? Simply substances with excess amount of electrons, which is negative ions. We learned that previously. So these are the two negative ions. We are ignoring this. We are only considering OH minus and Cl minus. We don't have Cl minus. So simply it's this. So you can balance this as I said previously, then put two H pluses. Then you can put 4 electrons like this. Right, come on. 4 electrons. Is it clear? You can put 4 electrons. Now, is this reaction correct? For an anodic reaction, this is the anodic reaction. Is this correct or not? Do we want to rearrange it? Quickly, tell me. Then what am I lazy? No, now these things should be really simple. Now we are quickly moving. Is this correct? That I said, if we had both OH minus and Cl minus, I said the priority is for Cl minus. Is this a reaction correct? No, this is not correct. Why isn't this correct? Why isn't this correct? We need to rearrange it. Why? Because OH minus is not the prominent one, it's water, as I said. So you need to rearrange this OH minus to make it water, which we did by adding 2H pluses. You need to add 2H plus this side, 2H plus this side, then you can rearrange it. We did it in the previous one. Is it clear? You can do it on your own, right? That's okay. That's what we learned. That's okay. But something different happens here for the cathodic reaction. For the cathodic reaction, something different happens. Here, for the cathodic reaction, what do we consider for the cathodic reaction? What is cathode? Accepting electrons. Who will accept electrons? Positive ions. What are the positive ions? It's only H plus. It's only H plus. So you can write H plus goes to hydrogen. You can put a 2 here. To balance this out, you can put 2 electrons to this side. Hurry. That's okay. This is the cathode. Is this correct or do we rearrange it? Is this correct or do we rearrange it? Do we make it water? The previous one we did. Ne? If you can remember here, this one, previous one, make ne? You see the same reaction, we added 2OH minus and made it water. I'm asking, are we doing the same thing here? Exactly. Good. That's what I want you to understand. Here we don't do it. Why don't we do it? The simple reason is, why did we transform it? Because here we did the transformation because OH minus is not the correct representation because we have water. We have a very little amount of OH minus. But for H plus, for the previous case, that was true. We had a very little amount of H plus because it was given from water. But here, this H plus is not only given by water, but given by the acid. So we have a significant or a considerable amount of H plus. Therefore, no need to change this. That's a special point which they expect you to know. They haven't said those. They have just expect you to study. But now you know why. Then it's easy to understand. So whenever you get H plus or OH minus, you need to change it to water. Unless you have an actual acid. If you have actual acid, then H plus can remain without being changed because there's a certain amount of H plus in the container. Right. Check whether that's clear. Check whether everything is okay. We have roughly 30 minutes. Finish the today's session. I might continue until 12:30 if I fail to do so. We'll see. Still, we don't have 1 hour, so try to give you maximum attention, right? Try to focus. I know now you might be a little bit tired. Same with me. But we have roughly 2 weeks, ne? We don't even have 2 weeks, I think, for your O levels. So those are the 4 cells for electrolytic cells which they expect you to know. Right. So what I'm planning now, as you can see, we have to rearrange our plan because we are running out of time. How do you suggest us to study for upcoming exam, like time management and stuff? Okay. So what I'm planning is we'll do it like this. Actually, we ran out of time simply because I didn't have a proper understanding on how much time it will take because I haven't taught this previously, the O-level theory. Now we have a little bit more theory for electrolysis, right? We have a little bit more theory for electrolysis. So we'll finish electrolysis complete. We'll finish everything. Then it will be roughly 12:15 වගේ වෙද්දි පුළුවන් ඉවර කරගන්න. හරි. And that's it. Then afterwards we have the final part, corrosion of metals. Corrosion of metals, and we need to complete few questions, which is the tute. What I'm planning is, if we arrange, let's say 2.5 hour, 3 hour session on this week, is it better to have it in a morning as a morning session or as a evening session? Can you have it at night, or would you prefer to have it like this? Any suggestions? Can we have it at night? Do you have classes? Morning, is it better to have it in morning? Is it so? Any time is perfect. Night or evening. So we have midnight is better. It's not good to study until midnight, especially for O levels. So I won't have it in midnight. That's not a good practice. Before 8, midnight is better. Morning is better. Okay. Then if it is morning, I don't have a lot of options if it is morning because I am doing my university studies in morning. So I'm attending my, so I'm, if you are doing a degree, you need to complete the internship period. I'm doing my internship as an engineer now. So I need to report to my work. So today I had to take a holiday for the previous seminar, the same. But like, how about a Sunday? Is it possible? Is it too late? Next Sunday. What is next Sunday? Next Sunday is shape. It's the 9th. Okay, I'll see. Most of the students are suggesting it's better if it is a morning session. But I'm not sure whether that's possible because next Tuesday is not, it's far away now. Today is 4th. Next Tuesday is the 11th. So that's not possible to have it on the 11th because your O levels are on the 16th. Because we can, if it's possible to finish it, we need to finish it early as soon as possible. Then, okay, I'll see. Definitely the cover up session or the remaining sessions, remaining part will be done within this week. I'll confirm whether it's a night or a morning and the date tonight. I'll confirm it tonight or tomorrow maximum. So it won't be tomorrow. It won't be tomorrow anyway, but it can be Thursday also. So if you are unable to join live, it's fine. Just make sure that you go through the recording because even for today's session, only half of the students are joining live. Others will be watching the recording. That's okay because some had to go to school, some have classes, some have extra seminars. That's fine. Hari, so I'll try my best to get an opinion from your side, or else because I have a tight schedule with my other classes and uni work. Therefore, we'll see. I'll inform that. Hari, because actually no point rushing the theory now. Can't finish it. I tried my best but can't. Hari, then we'll continue doing this part. Hari, here. So this part is Hari, ne? This part is okay. What is this? The electrolytic. So after this session is done, you can check whether you are okay with the electrolytic cells part, right? Electrolytic cells part, check whether you are okay with it. Hari, right? Write all the answers, write the reactions, and check with your textbook, or else you can ask me on WhatsApp. Hari. Then the final part. Sorry, we have two more subtopics to finish the part of electrolysis. Write one, electrolytes. Electrolytes. This is a subtopic. Now the main part of electrolysis is done. We know how to name a cell. We know how to identify a cell, how to write reactions. Everything is done. That's the main part. But few theories left. Write a subtopic, electrolytes. Electrolytes. Sorry. I'll try to finish by 12. Electrolytes. Right. Put a star mark and write. Put a star mark and write. A substance. A substance. A substance. In brackets, right, open bracket and right, mostly liquids or aqueous solution. Aqueous solution. A substance, in brackets, right, open brackets and right, mostly liquids or aqueous solutions. Mostly liquids or aqueous solutions. Close brackets. Close brackets. Close brackets. Mostly liquids or aqueous solutions. Close brackets. A substance, and then the bracket, then which can conduct electricity, which conducts electricity, which conducts electricity. Can you repeat? Okay. A substance, open bracket, mostly aqueous solutions or liquids, close bracket, which conducts electricity, which conducts electricity is known as a electrolyte. Is known as a electrolyte. Ready? Put another star mark and write. Put another star mark and write. Solutions which are unable to conduct electricity. Solutions which are unable to conduct electricity. Solutions which are unable to conduct electricity. Solutions which are unable to conduct electricity are known as non-electrolytes. 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 Sorry? Is it clear? Sorry. Now, write down the examples for electrolytes. Examples for electrolytes are ionic. So simply once you add that compound, okay, we'll discuss. Ionic, sorry, aqueous or molten, නැත්නම් fused කියලා කියනවා. Fused. Ionic compounds. Ionic compounds. Ionic. So it should have ions which enables the conductivity. Aqueous or molten ionic compounds is one example for electrolytes. What are the examples which we can write? Aqueous sodium chloride. Aqueous sodium chloride. Molten sodium chloride. Likewise, you can write any example. Aqueous magnesium chloride. Molten magnesium chloride. Anything. Zinc sulfate is ionic. Aqueous zinc sulfate. Molten zinc sulfate. Likewise, you can write any amount of solutions. The next one is strong acids and bases, because these will also provide a lot of ions to the solution. Providing the ions is the actual factor. Hurry. Acids and bases. So HCl, HCl, sulfuric, nitric. When it comes to bases, NaOH, KOH, I am writing the most common acids and bases in your syllabus. What about water? No, it does. It's not considered as a electrolyte. Why isn't water an electrolyte? Does water conduct electricity? Yes or no? Does water conduct? That's a good question actually. While you are writing, does water conduct electricity? No, water doesn't conduct electricity. Water has a very small amount of H plus and OH minus concentration, which we learned previously, but that's neglected. Then how do in the practical stages, water actually does conduct electricity? How does that happen? Why does that happen? Yeah, exactly. In water, it contains ions. It gets polluted. It's not polluted when water functions, when it rains or when we drink it or when whatever the procedure happens, Ions get dissolved in water. In our drinking water, there are ions. There are sodium pluses, there can be magnesium pluses, Cl minuses. Those things will actually make it conductive. Other than that, water won't be conductive. In your lab, the ions of the water has been removed, and that water is known as the distilled water, which doesn't conduct water. Therefore, water isn't a electrolyte. It's an unelectrolyte. Hari? Yeah. So the very small amount of H plus and OH minus in water doesn't make it conductive. It's negligible. So these are the examples for electrolytes. And for non-electrolytes in your syllabus, they have given hydrocarbons. Wait, I'll check what they have given. Yeah, hydrocarbons, water. They have given pure water or distilled water. Organic compounds, you can write because you don't know about those a lot. You can write organic compounds. Hari? Organic compounds, hydrocarbons, all are on the syllabus. You can just copy paste. I'm not teaching anything now. I'm just reciting what's on the textbook. And then water, which is important. Under organic compounds, petrol, diesel, all are organic compounds. Sorry, those aren't electrolytes. Those won't ionize. Those won't give ions. Those are non-electrolytes. None. Non-electrolytes. Sorry. If it is okay, sorry, if it is okay, write the final topic for the day. Practical applications of electrolysis. Topic and give me 1 minute. I want to share the textbook of yours to the smart board. That's right. The final topic is practical applications of electrolysis. We'll finish it within 10 minutes and then that's it for the day. Hurry, give me a minute. It's not visible, ne? How do you Very thought do. Okay, then it's fine. I'll just draw it and show it. Doesn't matter. Okay. Oh, fine, fine. Sorry, I tried to screen share it, but I think it's not possible for the moment. It's fine. It's fine. We'll just continue. Okay, under applications of sodium chloride, the issue of screen share is that it's too bright. Now the textbooks are white color and it's difficult to screen share. That's why. Doesn't matter. Under applications, there are two main applications which I want you to know, right? Which I want you to know. The applications are, right? The applications are yeah. The first thing is the down cell. The down cell. Hari, I won't write anything because everything is given on your textbooks. I'll just explain the most important two concepts. One is electroplating, and the next one is this one, down cell, which is extracting sodium from sodium chloride. Hari. So this is exactly the same thing. Now, can you remember under Roman number 3 of electrolysis lytic cells, I gave you sodium chloride liquid being electrolyzed under 2 electrodes. And I asked you to write down the equations and identify the cathode and anode. So this is the entirely the same concept, except since we are doing it as an industry, you can't just make a small setup and expect to do a mass scale production. Therefore, the cell is a little bit different. I just wanted to share you the diagram of the cell, but it's given on your textbook. You can just refer it on, I think it's on the 97th page of your textbook. Hi, on grade 11 textbook, it's on the 97th page. The setup of the down cell. So everything is similar. All the reactions are similar. The reactions won't change. The theory won't change. Everything is okay. Everything is similar. The only difference is you need to remember the cathode and anode, which is different. Now here both cathodes were carbon, but the cathodes are when different. Cathodes and anodes are different when it comes to industrial. So no theory, it's just memorizing. And apart from that, two more important points are there that you need to remember, which is not applied for theory, but which is practically applied when you are doing the down cell, when you are making the production in the industrial level. One thing is that, now what did we have here? What do we have? Sodium chloride liquid, right? So the first ingredient to get sodium out of the down cell, we need sodium chloride liquid. Do we get sodium chloride liquid easily? No, we won't. How does sodium chloride exist? Put it on the chat, Tagaradan. How does sodium chloride exist commonly? As a solid. Yes, as a solid. Sodium chloride will exist as a solid. Is it clear? Right, as a solid. Then it's difficult to actually heat it up and melt it down. Right, it's difficult to achieve the melting point of sodium chloride, but here, for a smaller scale, you can do it. But when you are fusing hundreds of thousands of kilograms, it's difficult. Then you need a lot of energy, which is waste in terms of an industrial point of view. Therefore, there's a theory point which is mentioned in your textbook. We add 40% of calcium chloride, which will decrease the melting point of sodium chloride. Now, if you are wondering how does that happen, you will learn those concepts in A levels. Simply, you need to remember always the melting points will decrease when you mix two pure solids together, right? So if you have two pure solids, so calcium chloride and sodium chloride, when you mix those, the melting point of the mixture will be less than both of the solids. Do you get it? So you can add calcium chloride and then sodium chloride, the melting point of the mixture will be dropped. Then you can easily melt it down. That's mentioned as one important point under down cells. Everything is on the textbook. I just want to explain it, then you can understand it easily, because reading the textbook might be not that easy to understand. That's one point. And also, when you add calcium chloride, it has mentioned that it's not on the textbook, but this calcium is highly dense than sodium. Therefore, in the cell, in the down cell, it will be deposited in the bottom. Therefore, it won't make any effect to the reaction. Sorry, a reaction now if calcium was floating inside the cell, then it will be a barrier or obstruction for the reactions. But since calcium is dense, it will go and settle down. Therefore, it won't harm any of the reactions. That's why we are adding specifically calcium chloride. Otherwise, we could have added something else. We are adding calcium chloride because after reducing the boiling point, after reducing the melting point, calcium will go and deposit somewhere else. Then that won't be an issue. Is it clear? That's the second point. Then the third point is that the products of this cell will be sodium and chlorine. You can write it. Now you know how to write the equations. The products of this cell will be sodium and chlorine. These two are the products. Hari, you can write. I asked you to write those previously. Once you write for molten sodium chloride, the products will be sodium and chlorine. This will be the product from the anode. This will be the product from the cathode. Hari, there's a possibility of these two reacting together after being produced. Right? There's a possibility that these two can react after being produced. Is it good? Is it good? No. So this is sodium liquid. Sorry. Is it good to react these two? No. Why isn't it good? Why isn't it good? Because our objective is to get sodium liquid. Then if it again gets reacted after we produce it, then is it good? No, it's not good. Therefore, even though here we aren't interested about it, in the industrial level, this sodium and this chlorine will be taken out from two different openings, and dividing those two openings, there's a diaphragm, which is mentioned in the textbook as well. You can clearly see if you check the 97th page, there's a diaphragm which divides both the openings because it avoids chlorine to react with sodium. Now, once I teach you, when you read the textbook, you will understand in a better way rather than just reading it. So there are three important points. First, to reduce the melting point of sodium chloride to make it easy to fuse, we add calcium chloride. Second thing is calcium is highly dense, therefore it will go and settle down in the cell. Therefore, it won't affect the reactions. The third one, the products sodium and chlorine has a possibility of reacting together, which will ruin the entire process. Therefore, we separate those two entries, the entries which we are getting out those products by a diaphragm. Check whether that's clear. Hari. එටික පොඩ්ඩක් ඔළුවේ තියාගන්න. That's for the down cell. That's for down cell. If you have questions, you can. I'm just explaining what's happening. That's the down cell. And the next main application is electroplating. If you want, you can write down cell and write what I gave you. If not, you can just mark it on your textbook. Right, what I said, up to you. The next important application is electroplating. Hari? Okay. So in your textbook, according to what I saw, all the theories regarding electroplating is just mechanically taught. Use this as the cathode, use this as the anode. There's no guidance given to how to understand why this is cathode, why this is anode in electroplating. So I'll teach you electroplating, doing a question on that extra session. So before that, I can teach it now, but the reason I'm not teaching it now is that you need to be okay with writing the reactions, okay with understanding all the concepts, cathodes and anodes. Now, if I do this, everything will be mixed up. So what I want you to do is, that's it for today. So you can write down the topic electroplating. We'll do it as a question on the next session, right? I'll definitely do it. I'll make a note on it. What I want from your side is, before joining the next session, try to join the next session live. If not, watch the recording. But before doing any of those, make sure that you can properly identify whether it's an electrochemical cell or whether it's electrolysis, and you can properly remember how the logics flow for electrochemical cells and for electrolytic cells, right? Is it clear? And afterwards, on the extra session, I'll inform the date and everything on the WhatsApp group. If you are not on the WhatsApp group, join the WhatsApp group. I have sent the link to the YouTube live. Zoom students should have the WhatsApp group. Definitely should be on the WhatsApp group. So on the extra session, we will be covering this electroplating part, then the corrosions of metal part, and then we will be doing the tute, which involves past paper questions. For that, we'll roughly want 3 hours, let's say 3 hours. So I'll arrange a 3-hour session for that and inform you on the group, right? Okay, so then that's it for the day. I think this session should be productive, right? I hope you got the maximum of it, and I hope that from now onwards you have a significant advantage comparing with the other O-level students, because what you know is not known by most of the O-level students, because this is A-level, which makes it easy to understand logically and easy to memorize. Very, very small amount we are supposed to memorize. So once you join this session, everything will be completed. And again, I'll send you a suggestion form, most probably asking for more suggestions. And all the we'll meet at least for 2 more sessions before your O-levels, and in between your O-levels, we'll say I can't confirm, we'll see. And also after your O-levels, I'll guide you for your A-levels. And if you are interested to join our classes, everything will be informed later, right? Everything will be informed on the group. So what I expect from you is only 2 things before your O-levels. Just get the maximum out of this. That's number 1. And the second thing is just spread the message among your friends, right? That's as a favor for myself and as a favor for your friends, right? And before we finish, where is this lesson tester? This is the 9A question. You can check the tute. All the questions are 9A questions from your level papers, most of the questions. Sorry. Then that's it for the session. Let's finish it for the day. If you have questions, you can ask, or else within 1 minute, I'll finish the session and also end the YouTube live as well. All the students on the YouTube live, make sure that you're on the WhatsApp group. Hari? Right, then that's it. Thank you for joining. Let's meet soon. Hari? Right. Yeah, thank you. You are welcome. No, normally they won't ask to draw down cell. They will give and just ask you to write answers regarding that. Hari, normally. Right. Okay, then I'll finish the session. Hari? If you have doubts, you can ask on WhatsApp. Right. Thank you. Right, then I'm going to end the stream. Hari?